Well, hopefully everything's working. Let's see if that's true. Okay, looks like it's working. Yep. So now I just need to make everything public, which I do. Oh. Wait, what? Where do I do that? Oh, there it is. That's really dumb. There should just be a dedicated button for that instead of having to configure it that way. Okay, now where did my stream tab go? Oh, there it is. How is ARL handling high memory frequency? Worse than the AMD APUs. I have a sneaking suspicion that AMD's 2-to-1 mode is like stability buffed by the massive memory bottleneck. So, right, we're just going to go to BIOS. Actually, no, we're not going to go to BIOS just yet. So right now the system is completely stock. So, and by completely stock, I mean literally JDEC. So, wait, did I not? I swear I fixed this yesterday. Why is it color fringing again? Windows. Yeah, no, it's just I freaking hate capture cards. Like I did like a series of videos complaining about how much I hate this, and I found a fix. And the thing is, you have to reapply the fix every single freaking time, and so it's just like, okay, I guess we'll just have to live with slightly less legible text than usual. Oh well. Well, the issue is the capture card issues are like they're fixed on the operating system level. So if I switch Windows installs or I reinstall GPU drivers, the issues are back. So, you know. I don't remember what the solution was. It was like rather convoluted. Okay, so XRGB makes it. Wait, what about? No. I give up. I'm not fixing that now. It's maybe slightly clearer. The other issue is just like, okay, well, that's way worse. is that like if I don't have it like pixel perfect scaling on my end, then it's also really hard to tell if it's just like a preview issue or whatever. Okay, we'll just go with this, and I'll just live with that, I guess. So the Gigabyte boards are kind of less obnoxious than ASRock in my opinion, but the thing is the BIOS is like missing a bunch of stuff. It's missing the same kind of settings that they were missing on Z790, Z690, and Z590. Okay, so at JDEC we're getting like 18 seconds. Actually, I wonder if there's... we'll worry about the tweaks later. Let's just go to BIOS now. Technically, I could afford to replace it, but like, why? Oh man, using ASRock like ASRock for some like I don't like ASRock on the Z890 OC formula for some reason advanced mode is on F6, which is just like Asus is on F7, MSI is on F7, Gigabyte's on F2, and then ASRock's over here all special like yeah, we use F6. You know, we could have used either of the other two F buttons for advanced mode, but nah, F6. Now, do I go... You know what? No, we're going to start by enabling XMP, and then we're going to check like if 200S boost makes much of a difference. Why does Gigabyte have missing settings? Because it's Gigabyte. Like, that's just how Gigabyte be. No, everything that's missing you can technically change in the OS. So for benching, it doesn't affect anything, which is kind of the reason why I suspect Gigabyte hasn't bothered to fix it, or they do fix it on their extreme overclocking BIOSes, and then the mainstream BIOS is just like, yeah, it's missing a bunch of functionality that you get on ASRock motherboards, MSI boards, Asus boards, because like, you know... Like, Gigabyte's own in-house overclockers don't need to use the retail BIOS, so why would anybody bother fixing it? And this is one of my whole issues with, like, special internal BIOSes existing, is like, yeah, so you have this special BIOS that, like, your own team uses, and then everybody else is stuck using the trash you put out for the public. Like, imagine if, like, AMD or NVIDIA had, like, special internal drivers that led to, like, better benchmarks, but only if you're an NVIDIA employee. It's like... Anyway, so let's just quickly check memtweak it. Yeah, so these timings are standard XMP stuff. Now, funnily enough, 200S boost actually does tweak a few of the timings, so that should help. Also, it should raise the clocks a bit on the D2D and NGU. The VF points are useless. So I've never, ever bothered using VF points on Intel CPUs. Like, any kind of dynamic voltage tuning to me is just like, I will not deal with this because it's going to take forever to verify stability. Okay, so 16 seconds. If she's drunk, I'm gonna have to ban her. Oh, we'll find out. We'll find out if she's drunk. It'll become very obvious after a few messages. So where did MSI put the 200S boost toggle? Ah, there it is. Okay, so it's not really. Without voiding the limited CPU warranty, overclocking results. Stability is not guaranteed. Yep. If you get really unlucky, 200S boost will crash your CPU. Oh, and it disables runtime overclocking. Wait. Did they mean timings, or did they just mean CPU overclocking? Whatever. Look, yeah, so the funny thing with high D2D is that it causes boot issues. Because, like, I had 3.8 gigahertz D2D working, I think both briefly on my 265KF, and then at some point it just broke and I never managed to get it working again, so ended up testing that chip with 3.6. And then I had the same thing happen with the 250K Plus, where it like worked at 3.8 for a while, and then it broke. And I just gave up. I was just like, okay, screw this. Especially because on the 250K Plus, I actually like tested how much of a difference there is running like, well, on like a 265KF, it's a big difference because the stock clocks are so low. But if you're on the refresh CPUs, they ship at I think 3 gigahertz for both. And so going from that like stock frequency on the interconnects to like overclocked interconnects, and I didn't even just do interconnects, I overclocked the ring and the interconnects at the same time. And it's like, I want to say like 3% more performance in games on average, if not even less than that. And so to me, it's like, you know what, with the D2D frequency is like, if I'm not benching, I'm not gonna it does. It kind of feels to me a lot like pushing 2200 FCLK on Ryzen CPUs. It's like, yes, it makes a measurable difference, but God help you with the kind of instability that you cannot run into. And actually, I'd say 2200 FCLK is much less of a problem than like high D2D, because as far as I can tell, that seems to be where all of the like, oh, the system doesn't want to boot anymore kind of issues come from. And apparently some other boards have a fix for that, but ASRock, I guess, doesn't, because the Z890 OCF is just like that motherboard not being able to turn on is such a regular occurrence that it's just like, yeah, like originally I started testing the 270K Plus on the OC formula, and then I just gave up. And also I need to test this MSI board anyway, because, you know, MSI sent it over for testing, so gotta do my job. But like originally I wanted to use the OCF because that's the board I've used more so far. So I was like, well, I'm, you know, more experienced with this board. But what I forgot is that most of my experience with that board is fighting the power button. So here we are. Also, what really bugs me about my complaints about the OCF's like inability to reliably turn on is when I say, oh, fighting the power button, most people think it's like, no, it's a problem with the physical power button on the board. And it's like, no, the board literally doesn't want to turn on. Huh, that's funny. Wait, what? I could have sworn 200S boost on ASRock was like tweaking refresh interval. Am I gonna have to like clear CMOS and try from there? I guess we'll have to try that. Because like on the OCF, like with 200S boost, it sets refresh interval to 32,000. And I thought that was 200S boost doing that, but maybe it was ASRock doing that. That's why, like, I don't believe in, like, doing motherboard performance benchmarks. It's like, yeah, like, most of the time if you see a performance difference with a motherboard after you turn on XMP or Expo, it's because the motherboard isn't following the profile. So it's like, it's not the, like, technically, if you're a beginner, it's like nice that the motherboard gives you more performance without you having to do anything, but it's not the motherboard is just better clock for clock. It's like, nah, the board is literally running different settings than all the other boards. That's why it's better. It's like if you copy the settings, the performance difference goes away. I have two options for RAM. Which would you? Crucial Pro, flares. Definitely the G-Skill sticks. Yeah, the Micron, like, I still haven't tested any Micron DDR5, but, like, it's gotten better, but as far as I know, it's still weird. Okay, so let's just try enable 200S boost again and see if, like, the issue previously was the order of operations on my part. Or if ASRock really is juicing the 200S boost profile. Because if I remember correctly, their XMP doesn't, like, turning on XMP on ASRock doesn't, like, do anything to the timings. At least I'm pretty sure it doesn't do anything to the timings. What? MSI's BIOS has looked like this since X79. Or more, yeah, like, okay, no, that's not technically true. They used to have, like, a bunch of big panels on the side instead of, like, having just a bunch of little menu options, but, like, functionally it hasn't really changed in my opinion. Like, where Gigabyte, Asus, and ASRock have all of your, like, main menus as like tabs at the very top, MSI always had them down the side, kind of. So, yeah, I don't know. That doesn't really seem like a difference to me. So they really don't do anything to the timings. That's interesting. Because I really thought, like, the OC formula was defaulting refresh interval to 32,000, so I figured that was part of 200S boost, but apparently it's not. Or maybe it only does that with, like, I don't know. Like, it was still this memory kit, so yeah, I have no idea. You turn on memory context restore. On AM5, depending on the situation, yes or no. So, like, when I was benching, so in winter, I ran the 9900X with the radiator outside the window, so, like, the water, like, to get better temperatures. And as it turns out, my 9900X, if the CPU gets below, like, 10 degrees or something, if you let it retrain the memory, it gets completely unstable. Like, it just falls apart. So the trick is that you dial in your memory settings on room temperature air, right? So at like 20 degrees ambient. Then you turn on context, then you like force enable memory context restore, and then you never let it retrain memory again. Because if it does and it's cold, it will stop working. So yeah. So it got like it depends. But for like a daily system, there's not like there shouldn't really be any reason, in my opinion, to not have it enabled. To like, because Yeah, like I've not run into issues with like, well, if I have run into like some motherboard, well, no, that's after memory retraining. So yeah, like I don't think I've seen a AM5 motherboard where it's like, well, actually, I mean, on 7000 series, there used to be an issue where if you had memory context restore enabled and power down mode disabled, after like a single reboot, the stability would just go completely to hell. But that should have been fixed like years ago. And it only affects 7000 series, but like recently I heard from somebody that apparently they still have that issue, which just seems impossible to me because I haven't seen that in ages, but I don't know. How do I like it so far? I've literally only like updated the BIOS on this motherboard so far. So don't really have much of an opinion on it yet. I think if your memory overclock isn't like crazy aggressive, MCR should just work. We're just going to start with XMP again. And actually, since I have 200S boost disabled, we should have real-time memory timing adjustments available. So we'll just mess with that, I think. 8000, and then we'll try go up in speed. I overclocked my RAM from 3200 to 3800 and didn't see a performance in game. Maybe the game you're testing doesn't care about memory performance. Maybe the way you overclocked your RAM was terrible. Like, is there a way to make OC RAM boot faster? Yeah, that's what memory context restore does. It just skips memory training. I would recommend not like so on AM5 motherboards you can like tell the motherboard to not spend so much time on memory training, which I think is a bad idea because that just means it's doing less verification. And, you know, if it's retraining every time and it's doing it quickly, then it's like, well, what if it screws up one time? Actually, we shouldn't be able to tweak cast latency in the operating system. It's like the one timing that you can't change after the system booted. Okay, so we're still getting our 16-ish seconds, so we're going to start with the most obvious and laziest of tweaks. We're just going to set refresh interval very, very high, like 1, 2, 3, 4, 5, 6 high. I wouldn't, like at DDR5 8000, I do actually think that's probably a bad idea from a stability perspective. Because, like, you know, like 65,000 at 6,000 is generally stable. So, like, 80,000 at 8,000 should generally be stable. Okay, so that shaved off like 0.3. It's nice. I was honestly actually kind of expecting more of an improvement. So, yeah, we got work to do. This should go down to 16 at 8,000. And it does. Wait, what? That didn't do anything? Does memtweak? No. I think AMD should, like, I want to say AMD will eventually support, like, real-time memory tuning, or, like, in-OS memory tuning, but they don't currently, as far as I know. But, like, as for, like, yeah, like, I don't know why they don't. Like, the memory controller has to support it because it's like a memory controller that's also used in like laptop CPUs. Actually, maybe the APUs do. Because if you have like a lot of laptop chips will have the ability to change the memory speed, and they also, when they do that, they also change the memory timings. So, you know, like the moment the system can change memory timings like while it's running, then it's like, yeah, you should be able to tweak the timings from the OS. But AMD just hasn't like made that available on Ryzen CPUs yet. So yeah, anyway, right. Oh wait, that's TRCDWR. I don't know why I said it like it's TRP. I have a 1700X3D and 6200 CL28. It's an X3D chip. You can spend an awful lot of time achieving absolutely no performance improvements. I have a video about tuning memory on the 9850 X3D, which is more memory bottlenecked than the 7800 X3D just by nature of being faster. And yeah, tuning memory on that is a horrible waste of time. You know, I wonder if I should maybe make the timings bigger, like that, maybe. That's all we really need right now. New Gigabyte AM5 boards. So the thing is, I haven't really had the chance to test much of Gigabyte's AM5 lineup in general. Like, I still haven't tested an 800 series 8-layer PCB from Gigabyte, which I'm quite annoyed about because they seem to be very good for, like, 4-dimmers. And so, yeah, obviously I want to test that. This should go down to at least 56. Yep. So technically WRWRSG, usually you can push it all the way down to like, well, okay, I shouldn't say usually. A lot of the time you can push it down to 48, but I have run into issues with doing that. And then if you tweak cast-to-cast delay long right, you can push it below like 48, but it gets weird. Wait, that's what? That made a huge difference. Or am I imagining things? Oh, and that crashed. Okay, let's see. Oh, please don't tell me the power button gave up. Hey, it still boots! Better than OC formula. You can crash hard from bad memory settings, and the board will still turn on afterwards without having to unplug the power supply. Amazing. I can't believe that that is something I get excited about now. Why is modern hardware like this? Is 4400 2200 CL24 a good idea on X3D? Yeah, like technically it'll perform very similarly to many other memory settings that you could run. I would still, like, the problem, like, personally, I think, because like, my experience with 2200 working is that it's more rare than, like, DDR5 6000 working. or even like DDR5 6200 working. Like DDR5 6200 works very, very regularly. 2200 FCLK, especially on 7000 series, is kind of rare in my experience. Now, I don't know if that's also true for late production 7000 series, because I have been kind of wondering if like AMD, because to me it seems that 9000 series AMD did something to make higher FCLK work more of the time. But so I've been kind of wondering if they weren't able to like backport whatever adjustment they made to 7000 series. But yeah, so like the 4400, 2200 FCLK thing, it's like on an X3D chip, it won't hurt performance as much as it would anywhere else. But it's like, do you really want to deal with the potential issues of 2200 FCLK? Like the main problem I have with it. And then the worst part is like when you do have stability problems with the Infinity Fabric, stress, like verifying it is just an absolute nightmare, right? Because the thing is, you can have very, very low error correction rates on the Infinity Fabric where it'll just not transfer data for like a millisecond, right? So for like a millisecond, the whole system basically freezes. Your stress test, if you're running LinPack, or not LinPack, if you're running yCruncher VT3 and you have a 2-minute time per workload loop, right? 1 millisecond of 2 minutes is undetectable. Like there is no way you can see that kind of instability, like 1 millisecond every, minute kind of instability. You're not going to be able to detect that from a performance measurement. But you know what you will be able to notice? When the audio hitches for 1 millisecond. That's very noticeable. So it's like, yeah, so because of that, like tuning the Infinity Fabric is just one of those things where like, I like running high FCLK is like, it's not that it doesn't do anything, but like if you can avoid it, for daily setups, I would avoid it because your stability, like it just saves you so much time and potentially so many weird issues that you can run into. Also, the FCLK stability like is kind of dependent on your memory performance. So with bad memory settings, the Infinity Fabric looks more stable than it really is. So it's not like you can go with like some very safe memory settings and then check if the Infinity Fabric is still stable or not. It's like, no. You kind of have to run both maxed out at the same time, and then it's just like, well, honestly, I'd rather just run less FCLK. Do the bottom, the fans over the memory sticks? Yeah, like those help. With Ryzen CPUs, those two fans can keep like 1.65 volt memory settings running at like 45 degrees Celsius. Now, the reason I say with Ryzen CPUs is that Intel CPUs run the memory hotter because Ryzen CPUs literally do not have enough memory bandwidth to be able to max out DDR5 sticks. They just can't. Arrow Lake can, though. And so it's kind of funny, like if you run the same settings on a Ryzen CPU as on an Arrow Lake, the memory on the Arrow Lake is going to be running like 5 to 10 degrees hotter depending on cooling conditions. Or even, actually, like if you have really bad cooling, it'll be even more of a difference, right? But yeah, so basically, if you have an Intel system, you really I would recommend RAM fan. Like if you're pushing DDR5 to its limits, I would recommend memory cooling fans on any system. But on Intel systems, they are way more important than on AMD, because on AMD, at least you're kind of stuck at DDR4 levels of memory bandwidth. On Intel, you aren't. On Intel, the CPU is fully capable of reading and writing 120 plus gigabytes of data per second. Whereas Ryzen CPUs are Ryzen CPUs are hard capped at like 70 gigabytes at 2200 FCLK, and the APUs can go a bit above that because, the APUs can go a bit above that because you can run higher FCLKs on those. Actually, I'm not sure if that works out for stress tests, because memory stress tests do a lot of writing as well as reading, and the APUs, I think, don't have full write bandwidth. I think they have like single CCD write bandwidth. I guess if you load up the iGPU at the same time, you might be able to get full memory bandwidth on an APU. Anyway, let's make this big again. Helps me see it too. That's interesting. Apparently these two made like a huge difference. There we are. We're at TCWL. Wait, that's 36. So I think like 72 should be a safe option, and then 48 over here. Okay. Are you excited about Nova Lake? I am... Honestly, I'm more excited for Zen 6. Because, like, I want to see AM5 without just the world's biggest memory bottleneck. Man, this is getting better scores than when I had the primary timings tweaked. That's why I say primary timings are overrated. Try that. TRAS on Arrow Lake is kind of weird. Because it's not like on AMD where TRAS like kind of doesn't do anything. It like, here it actually does something. You think Zen 6 will be much better? I hope Zen 6 will be much better. It's going to have a brand new memory controller. So it's not going to be like, it should be even like, the memory controller itself should be even stronger than what they have on the APUs. If the interconnect isn't one giant memory bottleneck, I think that would be really cool. But like, that's the part where it's like, man, I really hope they do something about the interconnect, because it's kind of ridiculous how with like AM5, you're running DDR5 at like DDR4 levels of peak memory bandwidth. It's worth noting that like you do still gain performance from like DDR5 even though you can't actually hit the peak bandwidth. Just yeah, I wonder, because the funny thing is there are games that are pretty memory bandwidth bound, right? And those games on Ryzen, like they just hit a brick wall, right? Like they just stop scaling, and there's nothing you can do. Well, yeah, there's nothing you can do about it. And it's like, yeah, so if we had a higher bandwidth interconnect, would those like run way better than they currently do? Because like there's games that like scale like crazy on Arrow Lake with just more memory clock, and then on Ryzen, well, they don't, because more memory clock on Ryzen just gets shoved into the same 70 gigabyte per second Infinity fabric. So when you see like performance gains from running like DDR5 8400 on a Ryzen CPU, that's because of memory latency. That's not because of bandwidth. It's physically impossible for the memory bandwidth to get any better. So yeah, so that's one thing I'm kind of wondering about. So you might notice I'm just tweaking this because this timing on Intel CPUs doesn't actually exist. And what I find really weird is, so the way memtweak actually like calculates this timing is it actually calculates it from this over here, which I don't really know why it does that, because this is a write command to power down enable, whereas this is write command to pre-charge. And TWR is normally like is normally meant to refer to this. And yeah, so anyway, let's see if that made much of a difference. Also, the way you would calculate TWR from TWR pre is you do like cast write latency, like you do TWR minus cast write latency minus 8. Yeah, because 8 cycle burst length. Well, that didn't really do anything, not that I was expecting much. Though I guess we could try tweak this. Oh, I probably have power down enabled. Yeah, so now you can see that like TWR updated. But I don't think that's going to make a difference to performance, because it really shouldn't. Like if Y Cruncher is running, the memory shouldn't have enough time to go into power down mode. And it doesn't. It actually got slower. There's going to be test-to-test variance. RTP, we're going to, like, technically at 8,000. Actually, yeah, we're just at 8,000, so 16 should be completely fine. TCK shouldn't matter. And so we're at 66 right now. If I want 48, actually, we could go below 48, but it's minus 20, like 87. TG heat spreader and use it for a delidded 9800X3D. I have one. I still haven't gotten around to testing it. I really like. I actually earlier today I was thinking about like I'm gonna actually set that up with just the 7600X, but you know like that CPU still runs really hot with the stock heat spreader. So it should still give us a good idea of if it helps or not. $6,400 gear down mode on better than 6,200 gear down mode off. I think 6,200 gear down mode off should have a slight edge. Also at 6,200, like if you can't do 120 nitro timings at 6,400 and you can do them at 6,200, I would definitely like if at 6,200 you can run gear down mode off and also tighter nitro timings, I would definitely go 6,200. Also, you will be able to save a little bit of power on SoC voltage, which, you know, it's not really a very relevant difference, but it's something. Is MCR on AMD trustworthy to use on Max RAM OC? Define Max RAM OC. Max stable for daily? Probably. Like, the issue is like, I don't, like, sometimes they put out a BIOS update and it breaks memory context restore. If you're trying to say SKUs and is in like different product variants, that's SKU. Don't ask me why it's SKU, but that's apparently what it is. SKU is like if you take a shape and like tweak it, like bend it, like bend it like diagonally. Like a rhombus is a skewed square. But product SKUs are SKU. And I guess it's an abbreviation for something. Oh, stop keeping units. Yeah, there. Okay. So, man, there's a lot of people who are like, man, memory tuning is so hard. There's so many timings. And then you actually go and look at which timings matter. It's like, no, there's not. There's not enough timings. Okay, so TXP was a mistake. I should probably just go kill power down mode. I bet, like, hopefully MSI made that easy. Hey, the power button still works. I'm liking this motherboard more and more. Every time I crash it and the power button still functions. Like, I don't know what they're doing over at ASRock. Like, how do you get a power button to not work like that? MSI unlimited settings. Yeah, that's what we want for Y-Cruncher. I should probably do more than all of my memory. Yeah, we'll see. We'll see if that makes more of a difference than all of my memory tuning. But also, let's go find power down mode and kill it. Though, funnily enough, I think for Y-Cruncher, turning off power down mode really shouldn't do anything. Because, like I mentioned earlier, if you're running Y-Cruncher, the memory should be under so much load that, like, there shouldn't be enough time to turn off. or like to go into power down mode. Also, you see how here we have like, you know, command, yeah, so we have address on die termination, channel 1, dim 0, GA, group, yeah, group A, group B, right, so yeah, that's distinguishing which memory chip in the chain. But this is dim B1, and then we have dim B2, and then we have dim A1, dim A2. So AMD's current like available resistance tuning settings are actually really simplified compared to what like DDR5 actually supports, because technically you can set those resistances for each individual memory rank in the system. And as far as I know right now, the way it works on AMD is that you set all of the resistances for all of the ranks at the same time. And future Ryzen CPUs should like get rid of that, which yeah, that'll be interesting. Okay, we have a bunch of training stuff. Interesting. So I wouldn't, like, I would assume that, like, power down mode is not in the training menu, but, like... Oh, wait, doesn't this BIOS have a search function? Oh yeah, it's... Wait, they literally just have Control F. Okay, power... Hey, we found power down mode. Disable. And that'll be it, right? So we disabled the power limits and we disabled power down mode. Let's see what that does. What? No, 8,000 is really low. Saw power down mode. Yeah, I'm not good at reading. Does memtweak it safe? Yes, as far as I know. Like, it doesn't allow you to change any voltages, so you can't really break anything like that. Any updates on the ASRock motherboards killing Zen 5 CPUs? So the thing is, I'm not sure anybody knows what is going on with that. Like, I don't know why that's happening. ASRock, as far as I'm concerned, also has no idea why it's happening. AMD maybe knows, but they're definitely not telling anyone. And the other thing I'm wondering about, like, yeah, like, I don't know. Like, there's a possibility that, like, and this is kind of just, like, a very out there theory, is, like, maybe the like frequency of reports of dying CPUs specifically on ASRock motherboards is that like ASRock got a lot of attention for like a couple random dead chips that were like normal product failure rate. And then now anytime another CPU dies on an ASRock motherboard, people like pile on. But it's not because like, so you get like more reports of dying CPUs on ASRock boards, not because like the ASRock boards are killing them more, but because they're more famous for killing them. Whereas if you have like a CPU die on an Asus board or whatever, you just send it back to the retailer, right? I don't know, like, again, I have no idea if that theory is accurate. I don't have any way of testing it. But yeah, as far as like, because I've seen like a bunch of speculation around like, oh, it's too much SoC voltage, but the SoC voltage has been locked down for like forever. And ASRock wasn't even like the most trigger happy with the SoC voltage out of all of the manufacturers. That's, as far as I know, still Asus, where they will happily default it to 1.3 volts even now. And yeah, like, and 1.3 volts is the limit set by AMD, so that's safe as far as I'm concerned. I haven't had any chips die since the 1.3 volt limit was imposed. I didn't really have, well, I had one 7950X die really like right around AM5 launch, but like I don't know if that was an SoC voltage death, because usually the SoC voltage deaths are like they have very different symptoms from mine. Mine just gets stuck on memory training forever. Nobody, like, which I guess is kind of more in line with what the ASRock CPUs are experiencing, where it's like you don't get the bubbled up substrate and 0, 0 postcode because the IO die is completely toasted. The CPU just never initializes. So I have a 7950X like that, but, that's 7000 series and it happened on an Asus board. Yeah, no, that was early on, before AMD imposed the 1.3 volt SoC voltage limit, but it wasn't just Asus. Like, everybody was setting SoC voltage really high because the memory controller on Ryzen 7000 series chips and 9000 series chips scales with SoC voltage. Like, you can just run higher memory clocks at 1.4 volts SoC than you can at 1.3 volts. It's just that at 1.4 volts SoC, your CPU will probably die in some random amount of time. Yeah, and that random amount of time is like some people it happens really quickly, and some people it happens after like months of uptime, which is why it was like why it launched, everybody thought it was fine. Because usually with overclocking and like running high voltages, you get some indication of things going out of whack because the clocks start getting worse. Right? Like if you shove way too much core voltage into a Ryzen CPU, the first thing you'll actually notice is that it doesn't clock any higher. Right? Like if you keep raising the voltage and you're just like running Cinebench or something, you'll notice that up to a point you see like an increase in frequency, and then past that point the frequency starts getting worse as the chip starts internally overheating. The Ryzen 7000 and 9000 series memory controller doesn't do that. Even like 1.45 volts SoC will potentially clock better than 1.4. Right, which is like really, really freaking high. But the thing is, the SoC voltage feeds way more than just the memory controller. And so chances are that, like, yeah, the memory controller loves SoC voltage, but something else doesn't, and then the chip just dies. Anyway, so we're now under 16 seconds without any memory tuning. So that's neat. And so, yeah, so when Ryzen 7000 launched, like, yeah, everybody was running crazy SoC voltages because, like, if you wanted to maximize the probability of a CPU running like DDR5 6400 1-to-1, the easiest way to do that was to just shove like 1.4 volts SoC into it. That actually works very consistently. Like even now, if you run like on AM5 motherboards, there are ways that you can bypass the SoC voltage restrictions. If you bypass those restrictions and you have a chip that it's like, oh, it can't, like it can run like 6300 with BCLK or something, or like a little more than 6300 with BCLK. Well, if you bypass the VSOC limits, you can probably run 6400 for like maybe a month, maybe 6 months, maybe 10 hours. I don't know. This is kind of the issue with that situation. Like, that's, like, the really like, yeah, like, generally speaking with, like, these kind of degradation events, well, actually, this isn't even degradation, this is just sudden death that the Ryzen chips are having, right? It's not like you get a warning like, oh, the memory controller is getting worse. It's just like, oh, chip doesn't post anymore. So... I would have thought 1.35 V-Core wouldn't be that high for a 5500. Some chips still died with 1. Yeah, but it's not the same failure mode as the chips that were dying at 1.4. Yeah, and the really high idle voltage is normal for 7000 series and 9000 series. That's AMD from the factory. That's not the motherboard vendors. Like, unlike Intel, AMD has a very, very rigid spec for how the voltage regulator works. Whereas Intel has all this like, oh, there's like AC load line and DC load line, and these are totally adjustable, and you totally should tune them because then you get more performance. And it's like, meanwhile, AMD's voltage regulator spec is like the CPU sends a vid request, and the load line is like non-existent. And if the CPU gets less voltage than the vid request, it will either crash or it will not run. Or it'll slow down. Not running is crashing. So like it'll either crash or it'll slow down. So like it better get whatever voltage it requested. Which technically Intel CPUs also have that functionality. That's the like CEP does that. Though that's not its intended purpose. Like CEP's intended purpose is something else, but the side effect of how it works is that if you give the CPU less voltage than it requested, it'll not run at full speed. But Ryzen CPUs have like AMD calls it I want to say system management unit, which just monitors like input voltages and currents and power draw and everything that like handles the entire boost algorithm. And so if that detects that the voltage isn't what the CPU requested, it just doesn't, like the CPU just doesn't run at full speed. Meanwhile, on Intel, the motherboard vendors were all like, yeah, we're going to disable CEP because it prevents us from undervolting the CPU below factory, like out of factory spec. And of course, then you had the server motherboards that didn't undervolt the CPUs. And so running a Minecraft server would kill your Intel 14900K in about a month. Just like, man. And so now Arrow Lake has a whole bunch of overclocking restrictions because Intel couldn't write a spec correctly, like for Raptor Lake, which I think is really lame. This really should be able to go below. Yeah, okay, so it was changing TXP that broke everything. I'm forgetting anything over here. Wait, this should be maxed out. Why isn't this maxed out? Oh wait, we're on XMP, right? It shouldn't be maxed out because we're on XMP. So what this does is it like changes how much the CPU can delay refresh to give it some more scheduling flexibility. I'm not sure if that's actually going to make much of a difference in a high load scenario like Y Cruncher. What? No, AC load line is like bizarre Intel terminology. Hey, we're down into the 14-second range. Only 800 milliseconds to go before I'm in the top 100 and get like real points for this. Gee, what's the top 150? Oh, I'm already in the, yeah. Okay, so I already have like a 139th score. For a 24-core Y Cruncher. Because the funny thing is, I never actually ran Y Cruncher on my 14900K, which is which I think retroactively it's a good thing. Or the 13900KS, or the 13900K, which I think is a good thing because now we have an opportunity to do that with this CPU instead. It would be really, really lame if it was like, yeah, I can't really bench the 270K plus because my 14900K score is better. So, anyway, but I do want to go faster than this. I think we're kind of done with like the easy memory timing tweaks for now. I think now it's just like more memory clock. That's the way forward. I guess I could mess around with like the workloads and stuff, but I first want to just go max like clocks and then, or get kind of close to max clocks and then worry about the software tweaking. Nah, so far I've left D2D and NGU stock. And, well, I briefly ran 200S boost. 17900 X3D to a 270K for... Wait, did you get... Wait, for 30 what? Like, you paid 30 to make that swap? Because in that case, that's kind of cool, but... Like, you had to sell motherboard... Oh, I guess you could keep the RAM, which is the expensive part. Well, yeah, that is technically the expensive part. Do you miss B-Die yet? No. B-Die is way more temperamental than Hynix DDR5. For a while now, I've suspected that Hynix DDR5 is actually better than all of the memory controllers that are currently available for it. Because with every generation of like better memory controller that we've seen from both AMD and Intel, it's just like, oh yeah, so now Hynix A-Die sticks can clock even higher. Right? It's like, so like, because you look at it like Hynix A-Die when on like Alder Lake is like, oh, we're running like, you know, 7,000-ish, 7,200. Then eventually I think Alder Lake actually got like a big BIOS update that made it possible to go up to like 7,600. But Raptor Lake was doing like 8,000 plus with Hynix A-Die. Then, you know, on Ryzen, it was like, oh yeah, Hynix A-Die does like 6,400, 6,600. Then the 2-to-1 mode update came out, where 2-to-1 mode stopped being completely useless. And suddenly Hynix A-Die on Ryzen was doing 8,000 plus. Now we have Hynix A-Die on Ryzen doing like 8,400, 8,800. On the Ryzen APUs, it does like 9,000 plus, right? On Intel, it does not, well... Actually, I think A-Die on Intel is kind of scuffed right now with Arrow Lake, but 24 gigabit M-Die is doing like 9,000 and 9,000 plus. So yeah, like to me it seems like Hynix made some like the Hynix memory chips are ahead of all of the available memory controllers, which is kind of crazy. Like, what did they even test them with? How do you verify your memory chip's I/O circuitry when it's this good and everything available is so bad? Data centers? Nah, they don't care. They just run JDEC. Why do we have so many voltage settings? Anyway, before we touch any of that, what I actually want to do is I want to try go up in memory speed. So we're going to try 8,600 first, because I've already tried like 8,800 and I think 9,000 with the CPU on the OCF, and it was very unhappy about that. So, which is concerning, because I got the 265KF doing 9,000 pretty easily, so it's like, I don't know, is the memory controller on this worse? Maybe, but I don't know for sure yet. I would be kind of annoyed if it's like, oh, the retail 265KF is the best. Well, it's kind of funny. My retail AMD CPUs are all horrible, and then I have like a bunch of AMD CPUs from sources, and a lot of those are really good. And then on the Intel side, it's like, yeah, my retail 265KF so far seems to be the best memory controller I've tried, and the CPUs Intel sent over are actually like either I got way worse, like either I'm doing something wrong with the review samples or they're just worse. And I don't know which it is. Actually for 8,600, yeah, 4252 actually makes sense. Actually, we can tune everything else in Windows, so like, let's just try this for now. This is Gear 2, so... The funny thing though with the 265KF is like I tried copying the like settings I used for DDR5 9000 in my first like video with the 265KF doing DDR5 9000, and yeah, those settings don't post anymore for some reason, and I don't think the OCF that I like updated the BIOS, so that's scuffed. But you know, that's like typical Intel DDR5 things as far as I'm concerned. Um, okay, let's see what 8600 does for our Y-cruncher times. The funny thing though is when I was benching the 8200, the 250K plus, it kind of looked like trying to push the memory speed super high. Just kind of doesn't actually help that much. In terms of like actual like performance at the end of the day, which kind of makes sense because like as we all know, most of the massive performance gains you get from memory tuning is from tuning the memory timings, not from higher clocks. But yeah, it's kind of like I will still be very annoyed if it turns out that the 265KF is the best memory. Well, very annoyed. I'll be mildly annoyed, not very annoyed because I mean, yeah, whatever. Like I don't at this point I just don't care that much. But yeah, so it's like yeah, if it turns like but the thing is like I want to be able to do that like performance scaling of like run I'm not sure if I want to do a test where I only change the memory frequency and don't touch the timings or also like change the timings because the thing is like as you go up in memory frequency the timings get proportionally longer. So the actual like most of the timings in terms of nanoseconds actually don't change. Oh, we crashed. Let's see if the power button gives up. It turns off. And it still turns on. This right here. This right here where it's like, oh, it just completely froze scenario. That was the moment where I was like, okay, the OC formula is getting off of my desk and back in its box. Because I ain't dealing with that. I crashed. I don't think I crashed in Y-Cruncher. I think I crashed in Carhu. And I was just like, okay, I'm done. I'm not putting up with this behavior any longer. Like, you do not... Like, no, you can't just crash and then refuse to turn on. Like, that's stupid. But that does mean we have an issue here where it's like, this doesn't want to run and I wonder why. Like, SA voltage is already pretty high. And I think I have the timings right. Like, it's not like I'm changing anything else, so, like, this can't be my fault. And that is a lot of system agent already. Yeah, it even goes red. And the thing is, for Arrow Lake, I was told a very, very low max SA voltage that I was like, you know what, this advice seems overly safe. I am going to ignore it in the interest of being able to make videos about high memory clocks. Wait, what do you mean? Wait. Oh, that's the VRM settings. SA load line calibration. Yeah, we want that flat. And why are there two SA voltages? Sets the SoC SA voltage dynamic. Man, I'm assuming this is some internal regulator that just passes over, like if I set it to 1.4, it's just going to pass through system age, like the input voltage. This might help. Oh, MSI limits that to 1 volt. That's really low compared to a lot of other motherboards. VDD2. That doesn't matter as far as I know. DRAM voltage. This should be fine. Like, we shouldn't need more VDDQ on Arrow Lake. This isn't Ryzen, where once you go to like high 2-to-1 mode, you just need heaps and heaps of I/O voltage to get everything working. Alright, where are the like pass-through voltages for the memory controller? Oh, that's going to be in here, isn't it? No? Oh, we should disable that. This sometimes like eats performance for no reason. The ASRock motherboard had like a whole set of... And the Gigabyte board did too. Or there was just like a whole bunch of memory voltages. This is not it. So, like, did MSI just hide all of that? Because there's like a bunch of voltages that get generated by the CPU from VDD2. And I can't see those, as far as I can tell. Okay, well, let's just try it like this. I didn't really change anything, so I don't have high hopes for the stability to get better right now. This is weird, though, because I did briefly try 8600 on this motherboard before the stream. I don't think I really ran anything. Well, like, the thing is, the transistors keep getting smaller, right? And the CPU manufacturers aren't like, as far as I know, with the motherboard manufacturers, they do give them, like, some support for, like, figuring out, like, safe limits for overclocking, or safe-ish limits. But yeah, like, what I've heard about Arrow Lake is that, like, it's apparently super fragile. Or it might be super fragile, and it's just like, yeah, but, like... and the thing is like, I'm not gonna test that. Oh no, it's still crashing. That is quite surprising to me. And the other thing with like degradation, like I mentioned earlier with the like Ryzen CPUs dying from excessive SoC voltage, like some CPUs died really, really quickly, and some CPUs took like basically didn't take any damage at all, right? And so in those kinds of scenarios, it's like, yeah, so, you know, if you test one CPU and it's fine, it's like, yeah, but that doesn't mean anything. If you test 10 CPUs and they're all fine, it still doesn't really mean anything. Okay, I'm not sure how I want to approach this situation. Because, like, I really want to run 86... Like, I want to run high memory clocks, right? Like, that's the whole point of Arrow Lake, is high memory clocks. Okay, I guess we'll try 8466 first, see how that goes. This is the Tomahawk 2. It should be a newer memory topology. I think MSI claims support for 9000, but the thing is, like, this CPU, I couldn't get 8800 working on the OC formula, so chances are I've taken a bad chip and that, like, it's gonna make the board look even worse than it is. Yeah, MSI claims support for over 9200, though if they're using 4-to-1 mode, that might be kind of cheating. MSI claims 9066. Oh, so maybe a BIOS update? Or or they just binned like 100 chips to find one that does 9066. Actually, I think that's really dumb on like the Ryzen motherboards is when you see the crazy high memory speeds that they advertise, you always have to check is that with an APU or not? Because the APUs on AM5 are just insane for memory clocks. Like, I booted DDR5 10000 on the 8600G with, like, not even trying. Like I wasn't going for max frequency. I was just like, I wonder how stable this will be. It wasn't stable at all, but it was screenshot capable. Easily screenshot capable. And then I tried to do, like, 10400, and then it was upset. But that was, like, 2 memory sticks. I think if I only went with 1 memory stick and... yeah, and what's also kind of frustrating to me, especially with the APUs, is they have much fewer memory tuning options than the CPUs do, which is kind of lame because it's like, oh, well, at the same time, it makes sense because, like I said in my video testing the 8600G, like, it's not a good CPU, right? Like, it's cool that it's got like this really powerful memory controller. It's just attached to a kind of horrible CPU, so it's just, you know. It's kind of like Rocket Lake, where it's like, yeah, this actually no, Rocket Lake's memory controller is upsetting. Is there an equivalent? I guess it's like Arrow Lake, where it's like, yeah, you have a whole lot of memory controller strapped to a kind of slow CPU. Okay, so this works, and it is faster. Like, why is 8600 so scuffed? Like 10,000 in terms of like today's DDR5 overclocks is not really that high. Like the records on the APUs are like 11,000 on the memory. Also, I briefly stress tested the 9600 setup I did for the 8600G testing, which it was like the settings I used for the game testing weren't very stable, but I did get it to like pass like 4 hours of Karhu, and then I think it crashed in Y Cruncher. But I wasn't like, you know, the thing wasn't like, the whole issue I had with that is like, yeah, I don't really see much point in doing a whole lot of memory stress testing on a CPU that you really shouldn't be buying, right? Like it's cool that it can run those speeds and that it's pretty stable, but should you buy an 8600G or an 8700F? Which, incidentally, in the Czech Republic, there's a store selling, like, tray 8700Fs, and they're, like, a really, like, they're a very low price. But and that was what kind of led me to, like, you know what, I should really test the 8600G before I buy something really, really stupid, like an 8700F. Because it's like, yeah, it's like an 8700G, except way cheaper and with no iGPU, so it's just a memory controller and a very mediocre CPU. I bet the 5700X3D gets better gaming performance than the maxed out tune of the 8600G. Anyway, so let's see. Like, I don't think 8600 should require more, like, I don't think that should require any more, SA voltage. Or at least I really hope it doesn't require any more SA voltage. But what it could maybe benefit from, and you know what, I am not sure about that. I'm just going to put that back to auto. Maybe 1.45? Though I've heard that apparently even VDD2 can break arrow lakes if you like put too much stress on the memory controller. So like, I don't know. Like for some reason, like 1.45 volt XMP kits are very, very common. But Intel, for the 200S boost, only supports 1.4 volt kits. And so it's like, I don't know, did they test that 1.45 volts is actually dangerous, or are they just being overly cautious? So like the funny thing is like I have I have two memory kits that are like technically within 200S boost spec, and neither of them is Hynix A die. Or, well, they're like, if you go for 200S boost at like high frequency, at DDR5 8000, because technically, like, yeah, lower rated kits don't usually use 1.45 volts. Yeah. Yeah, super chats are now functional. It's a good thing I did that test stream last time. Nah, I think latency is going to be coming down. Honestly, I am super surprised that Intel's like Arrow Lake is as bad on memory latency as it is. Because like they have a much better physical connector than AMD does. Like AMD's Infinity Fabric is basically modified PCIe. Okay. Like that's literally what it is. AMD took a look at the PCIe Gen 5 spec and was like, what if we strip out all of the like redundant safety well, not all of it, but a lot of it. Like there's a bunch of like stuff that PCIe does to like improve data integrity. It's not even signal integrity. PCIe just accepts that like, oh, the signal integrity is kind of garbage. So there's like a bunch of adjustments that it makes to try work around that. And as far as I know, the Infinity Fabric ditches all of that. It does still have like error correction, but it doesn't have quite like it doesn't work quite the same way as PCIe, but it's vaguely based on PCIe. Because AMD was just like, yeah, we're not going to design like a custom, fancy, expensive interconnect when we can just mod PCIe to do this. And then it's like, yeah, and so that's why Ryzen AM5 CPUs have like the same levels of memory bandwidth as DDR4. And meanwhile, Intel's interconnect is like, yeah, it can move all of the data in the world. It just takes forever in terms of latency. Okay, so that improved the stability. It did not fix it. That is very frustrating. As far as I know, the IF is definitely getting upgrades for Zen 6. I'm like, yeah. I don't know how big the upgrades will be. I'm really hoping that they at least double the width, because it's ridiculous that like because right now like a lot of people think like, oh, if you have a dual CCD CPU, the bandwidth gets doubled. It doesn't. The write bandwidth gets doubled, but that's because the write bandwidth is like where the read bandwidth is like DDR4 levels, the write bandwidth is half that on a single CCD chip. Right, and so if you run a memory stress test like Karhu, it runs way faster on a dual CCD CPU like a 9900X or a 9950X Not because there's more read bandwidth, but because if you're running a memory stress test, you need to write things to the memory and then read them to check that they were correctly written. Right? Which is very atypical for a CPU workload. Most CPU workloads have way more read than they have write bandwidth, right? Because if you think about it, if you're adding two numbers together, right, and storing the result, you need to read two numbers and then store the result. And actually, you're not just reading two numbers, you're also reading what to do with those numbers, right? So it's like, okay, so first we read we read what we're doing, we read our inputs for what we're doing, and then we have one output. So you have like a 3-to-1, read to write ratio. And if the data manipulation gets even more complicated than that, like you could add up like 10 numbers at the same time, and it's like, yeah, so you'd be doing read, and then one write at the very end of all of that. And it's just, so like, yeah, so AMD's design where it's like, oh yeah, there's like no write bandwidth, makes perfect sense, because yeah, realistically, you don't actually need any write bandwidth. It just doesn't matter. But the end result is that when you run a memory stress test on single CCD CPUs, they run really, really slowly. Because memory stress tests do like a lot of writing. And AMD CPUs are just like really, like they're bad at reading, but they're even worse at writing memory. But why the hell is this still not working? Okay, well, we're going to do something that I really strongly don't recommend. We're going to go to 1.45 SA. If this fixes it, I'm going to be so upset. If your BDI dual rank needs proc ODT 4.36, yeah, that's completely fine. Like, for some reason, like somebody, like I remember like people, when proc ODT first became like available on AMD motherboards, for some reason, a lot of people have at the time, like a bunch of people were like, oh, if you set it too high or too low, you could like damage something. And it's like, but that's not how it works. Like it's a resistor. And arguably, if you set it too low, you could pull, like the thing is, it would just pull more current from the memory stick. It's not going to pull current from the CPU because it's CPU side termination. So it's just a resistor that connects to ground? No, it connects to VTT, if I'm not mistaken, for DDR4, not ground. If it crashes faster, try lower, obviously. And this is about the same. It just crashed. I think I was getting better memory speeds working on the Gigabyte Z890 Elite Ice board. But that board sometimes does the thing the OC formula does, where it like doesn't want to turn on. It does it a lot less often, but I have had it do that. Okay, I guess we're stuck at 8466, which is very lame. But like I don't feel like trying to like forcing more memory speed out of this is evidently not the way. Or like, yeah, it doesn't really want to do that. And we're just going to leave those linked for now. Is it worth spending an extra 130, 140 on a 270K when I can get a 265K for 310? I mainly use After Effects, Premiere Pro, and Blender. Unless you're using a B series motherboard, I'd say no. Because like the thing, if you have a 260, wait. 130 to 140. Yeah, that's like a 30% price increase, isn't it? No, that's almost 50. Yeah, so that's like a 40% price uplift. It's not going to be 40% faster. I mean, I like if you look at the overall change in your system price, but like the thing is, if you have a B series board, you don't have access to 200S boost. They might be in a region where the CPUs are a lot more expensive. I mean, if you go with the 265KF or K, I see no reason to not just stop at like 3.2 gigahertz on both D2D and NGU. And the thing is, like, the core count between the two CPUs really isn't that different, right? Like, with the 270K, you get, what, 4 more E-cores? And that's just like, it is a difference. It's not that big a difference, though. I wouldn't call 8466 on a 4-dimmer lame. The thing is, I'm pretty sure I have a different 4-dimmer that clocks higher than this. But that 4-dimmer was tested with the 265KF, and like my experience with this 270K so far on every board that I've tried it on, I feel like the board is underperforming. So, you know, what's the common variable here? It's just a real shame that my best motherboard is an OC formula. Oh, you have a Z890 Pro RS Wi-Fi. Yeah, then like I would go for the 265K. Yeah, the thing with the OC formula is if you crash that motherboard, it'll regularly the power button just stops working. So I don't have any ASRock contacts. So I don't really have I literally do not have a single ASRock email that I could send them an email and tell them hey, your motherboard regularly doesn't want to turn on for no apparent reason. You might want to fix that. Because it's really annoying. Well, if it was just overclocking failures, sometimes that board won't turn on for, you'll turn it off and it just won't turn on. Yeah, you have to power cycle the PSU. So far on this MSI board, we haven't had to do that a single time. Which is just you know what? Honestly, being stuck at lower memory clocks than everything else, if I don't have to fight the power button, best Z890 motherboard right there. Because you know what I want from a system that especially if you're looking at Z890 as a daily system, which a lot of my audience probably does. It's do you want to you know, sit down in front of your computer, press the power button, and then it like does nothing because the board just decided that like it doesn't feel like acknowledging the power button? Because I don't. And then you have to like crawl behind the desk to unplug the power supply. And then you have to wait several seconds because depending on your, like some power supplies will discharge the bulk caps really fast, but some don't, right? And if you have one of those power supplies where it takes like a minute before the bulk capacitors discharge, that's great fun. And then you need to crawl back under the desk to plug the damn thing in again. Or I guess you might just stay under the desk at that point. And then you can turn your computer on. It's like, it's a great user experience. You thought waiting for memory training for several minutes was bad. Well, wait until your motherboard just doesn't turn on for no reason. And I wonder which one did that. Yeah, like I have a Z890 Aorus Elite that I bought because I was so annoyed with the OC formula that I was like, I can't do this anymore. I need a different motherboard. So I bought that because at least like looking at the product specs, it looked like it was using a maybe better topology than some of the other Gigabyte 4 dimmers, and it has a post code, and I think it has a power button. Like on paper, it looked good, and so I was like, cool, I'll just buy this. And I think it's on an 8-layer PCB. And yeah, unfortunately, I didn't get around to like, you know, like fully testing the motherboard and doing a PCB breakdown of it yet. For reasons. So yeah, but I wonder what I just crashed it with. Yeah, okay, I didn't think it would have been that. Okay, what about 22s? Still good. Could it have been RTP? Because, like, I don't think... Okay, let's try 74. Works. 52? Works. Okay. What about... Oh, I can't type into that one. Let's try 60. Okay, good. What about 56? Huh, okay, so it was probably one of these two that I set too low. I already went under 15 seconds. That's disappointing. 680. Oh, there we go. Still 139th. But 8466, like 50 TRCD should work. Oh, TREF IX9 is back to not being maxed. Hey, there we go, 14.7. Oh, that's a big jump. Yeah, that puts me at 133rd. Faster than a 6 gigahertz 13900K. I'm actually going to check what that score is running, because it's like kind of surprising to me. Huh. Yeah, well, the 13900K doesn't have like AVX 512, so like that's the one issue with the 24 core rankings is if you look at the very top, it's just Threadrippers because of AVX 512, and then some like Intel Xeons because of AVX 512. Okay, so now what though? I mean, I guess I could completely max out refresh interval. See what that does. At this point, it shouldn't really do much, but... And it doesn't. And then two, I think that was just some, like, maybe it was like a low clock challenge or something? I don't know. I need to get my chiller working again. Actually, it should be working. I just haven't checked if it still works. But, like, the pressure gauge looks correct to me. It's been, like, 10 years since I last saw it, so... Yeah, but I haven't, like... Well, first of all, it's currently, like, the room is still, like, very disorganized. But, like, yeah. Hopefully, this year, I get that thing working. Be kind of cool to maybe do like a birthday stream where I have the chiller working. Or I guess I could just buy liquid nitrogen at that point. But nah, like chiller working would be cooler, I think. Because the nice thing with the chiller is the one I have, at least if I remember correctly, this thing should be capable of doing 4 GPUs like at minus 20 degrees Celsius. It should be able to handle like 1,000+ watts of heat load. So like... And I literally do not have enough LN2 pots to run a 4-way GPU setup. I mean, I don't really have the water blocks to run 4-way GPUs either, but water blocks are way more available than LN2 pots are, especially for GPUs. And then also, like, running quad GPU on LN2 is hell. Absolute hell. Because, yeah, you do not have enough hands to keep all of the temperatures under control at the same time. I want to try something. Let's try that. Yeah, quad GPU is the kind of thing you do with like at least one other person. Or actually the way I was thinking like handling quad GPU would ideally you would pre-bin a bunch of like NVIDIA 10 series cards for full pot. Because I have a 1080 Ti that like you can just like it just works at minus 196. It reboots at minus 196. Like, you know, so if you find 3 more cards like that, which as far as I know with 10 series is a bit random, if you find 3 cards like that, then it's like theoretically very easy to run. Like you could run it solo at that point. And then you just need a CPU that runs full pot, which unfortunately that's a lot less common. What cooler do you use? Right now, this is being cooled by a 360 millimeter Cooler Master Atmos something. I think I got it on sale. I gotta say, I'm really disappointing with the mounting backplate that it came with because it's just plastic. But on the other hand, like I also bought a bunch of Arctic Liquid. Okay, not a bunch. I bought a pair of Arctic Liquid Freezer 3s to use on like some of the memory test or well, to just use for like testing. I hate the mounting hardware for that cooler. Like I can, from a, like an engineering perspective, having the leaf spring and all that is like, okay, this is very cool and sophisticated and really inconvenient because you literally, like, even if you just unmount the cooler, like if you unmount the water block, which already requires a screwdriver because it doesn't have thumb screws, you still can't pull a Ryzen CPU out of the socket because the mounting brackets block the lever for releasing the CPU. So you need to undo at least one, so, you know, this is very like reviewer problems or like tester problems where it's like, this requires a screwdriver and more screws than just like Asetek AIOs, and I don't like it because of that reason. Really good cooling though. Yeah, the convenience of like swapping CPUs with that is horrendous. Yeah, why would I get an OLED cooler? Anyway, this seems to do a pretty good job as far as temperatures are concerned, and it's like the fan speeds on it are reasonable-ish. So if I find another cheap one, because this one might have been like open box or something, because I remember being like really happy that like, oh, this was cheap and nice, and then like later when I was looking to buy more coolers, I was like, oh, it's not cheap anymore or something. Like I don't remember what exactly, but I was like, it's not as cheap. So I went with the liquid freezers because the thing is like, and this kind of annoys me that Arctic, when it comes to like value for like fans or anything, it's just like, how are they so much cheaper than everyone else? Except like Thermalright maybe. But Thermalright isn't like a super common brand in the Czech Republic. So here it's just like, oh, I want a 120 millimeter fan, Arctic. I want a 140 millimeter fan, Arctic. 80 millimeter, Arctic. 92 millimeter, Arctic. I want a water cooler, Arctic. So it's like, because the alternatives are like, you know, because like for like say the 120 millimeter fans is like, yeah, you got the Arctic fans that, and then everything else that's like a high performance fan is like twice the cost. And I'm just like, yeah, I'm not paying twice as much. Like, it's just no, it's a bit of spinning plastic. I am not paying double. I don't care if it's brown or RGB. And that actually, like, I was even like, because for my daily system, I run a 7800X3D. I don't need crazy cooling, and I do kind of like colors, right? Like, my motherboard collection has several motherboards in it that are literally just there because they're a fun color. And so I was like, you know, maybe I could put a bit more RGB in my daily system. And then I go look at RGB fan prices, and it's like, oh yeah, the cheapest option is Arctic, because of course it is. It's like half the price of all the other RGB options. And so Arctic has been like slowly been taking over my cooling, like hardware options, because they're just so much more cost effective than everybody else. And I do think that's kind of lame. You interested in the laptop world? Not really. I have some Asus Ryzen Tough laptop. It's fine, except for like the NVIDIA GPU in there is a horrible thing. Like the power management on that GPU never works properly, and so like basically my options for using that laptop are like either the NVIDIA GPU is active and I get good gaming performance and horrible idle power consumption, or I turn the NVIDIA GPU off and the laptop becomes way better at being a laptop, but no gaming performance. Okay, that's not true. The APU GPU isn't that bad, but it's pretty bad. Also, like if maybe AMD opened up some like memory tuning options for the APU in there, then like you could make up some. Well, it would still not be as fast as the mobile. What is it? 5050, I think it is, or something like that. It's not a high-end GPU, but yeah, like that NVIDIA GPU just makes that laptop so much worse at being a laptop. And then like the way to like turn the NVIDIA GPU off is really inconvenient, which just annoys me. Because if it was like a quick restart to like disable and enable that NVIDIA GPU, it would be like fine. But the last time I tried disabling that, like after the last time I fiddled with like if the GPU is enabled or not, like I like that it took so much, it was so annoying that I'm just like, no, I'm not dealing with this anymore. And now it's permanently on and the battery life sucks, and it's just like, well, at least I don't travel very much. So it's not that big a deal, but I do think it's really stupid that like the idle on that GPU is so bad, and then there's not even like a nice way of just quickly turning it on and off. Because that's like, I think that's one of my biggest frustrations with a lot of like modern power management stuff. Instead of giving the user control over, hey, do I want all the performance or do I want power, like battery life right now? It's like everything has to be automatic, and of course the automatic system is stupid and broken, so it doesn't work, and you're just stuck with the worst of both worlds, where it's like, yeah, my battery life does suck, and the thing is right. Well, I guess the gaming performance is still fine. Like, at least it doesn't do that. Like, it used to, like, I remember, like, I don't know, like 10 plus years ago, a regular issue I'd have with laptops is that they would just refuse to boost when playing a game. So it's like, oh, the game is running like garbage. Why is that? Because the CPU is at 2 gigahertz while it's not overheating. And it's like, well, that explains why it's running like garbage. Anyway, I wanted to tweak the core clocks. Where are those? P-core. Actually, maybe let's do the interconnects first, because that's generally less of a problem. As far as I know, like this is an 8-core, so 42 rings should be the limit. NGU 32, D2D. Let's try 36, because that's usually like a nice safe option. And I shouldn't really have to do anything else, because like my I already maxed VNN AON. So this should just work. Well, 36 is safe for D2D, yeah. Unless I'm mixing up the order of them. The 270K well performing. Can you test it in Tarkov? Does Tarkov have a built-in benchmark? Because if it doesn't, then no. Yeah, then if there's no built-in benchmark, I'm not running it. Does Forza Horizon 6 have a built-in benchmark? Yeah, so you say, like, the issue is like, if you, like, with the game benchmarking, it's like, I don't like dealing with external freaking FPS monitors, and then, like, manually having to do the then I have to set up something to, like, do the data processing, And it's just like, no. Forza Horizon 6 does have one. Cool, because I've been considering buying the game, and if it also has a built-in benchmark, then that's just added value for me. So the 270K Plus is very memory bottlenecked. Same as the 250K Plus. And based on, like, the thing is, I'm not done with all of my testing. Like, I still haven't tested a non-X3D 9000 series CPU, and I haven't tested Raptor Lake or Alder Lake, but Raptor Lake being the more important of the two. And I'm not entirely certain that my 250K Plus testing is applicable to the 270K Plus, or like if I like there's like some methodology changes, like instead of using the 9070, I'm now using the 5080. So, you know, like one of the goals of this stream is to end up with some vaguely, like, is basically get a better feel for the CPU, so I have some vaguely stable settings that I can run gaming benchmarks with. Because, yeah, when I was trying to just, like, speed run my way on the OC formula to, like, get gaming benchmarks done with this CPU, it was not going well. And the thing is, like, you can't do that with Windows 11. Like, Windows 11 is so fragile, especially, and games are fragile as well. Like, yeah, like when I was testing one of the Ryzen CPUs, I corrupted one of the game installs through Steam. So it's like after that, I was like, okay, so basically, if I want to do, like, if I'm on a platform where I don't know it really, really well, I need to run like a install that's like what we have here, where it's just testing. And it can't be Windows 11 because like that OS, like Windows 10 is already kind of fragile, but Windows 11 is so much worse. Or at least it seems so much worse in terms of like fragility to blue screens. Oh, I'm gonna have to redo all my memory timings. So yeah, like get all these settings set up and then go test the CPU with Windows 11 and all of the games that I'm testing, which isn't going to include Forza just yet, but probably will at some point in the future. Oh, I know. Whatever. I don't think in the past mainstream channels were really benching with very good overclocks anyway. Like the only overclock testing, like it used to be standard to do like CPU overclocking as part of like CPU reviews, but like the only reason they did that was because the CPUs had like a bunch of overclocking headroom, right? Like in the Sandy Bridge days, you could go from like 3.3 gigahertz to like 4.5, and like, yeah, that would make a big performance difference. But it's been a long time since CPUs had that much headroom. That's actually why I tested the 250K Plus before I tested the 270K Plus, because the 250K Plus comes at a lower factory clock, so there's more room for improvement. Am I stupid? This is like the same time we were getting before. I mean, yeah, I didn't run the really high refresh interval, but like Didn't I boost the D2D and NGU? Like, why isn't it doing anything? Yeah, this is 3.6 and 3.2. Like, what? Does memtweakit still get updated? Yeah. Like, Asus puts out updates for it basically as new Intel platforms come out. Okay, 14.6, not bad. I think that's a bit of an improvement. I mean, maybe the settings here aren't ideal. Yeah, because as far as the CPU overclocking on the 270K Plus is concerned, I expect, like, my expectations are to maybe get like 4% more out of like core overclocking, because it's already at 5.5 on the P cores. What I'm more interested in testing is like turning all the E cores off and see what happens, because I just want to know. And I'm not like saying that's a good idea, okay? Just let's be very clear. That's more like, that's just like a I wonder kind of thing. And then, yeah, trying to, I don't know if you can turn off all the P cores, but I know you can definitely turn off at least 7 of them. So I am wondering, like, what happens if you just have one P core. But the funny thing is, like, if you run something like Pi Prime over here, if you run that on an E core, it runs really, really slowly. Like, if we run it on a P, or right now it's going to default to running on a P core. All right, so this is 2 billion. That's, I think, the short one. Yeah, and so that finishes in 8.6 seconds, which I think is actually pretty comparable to like even Ryzen X3D CPUs. But if you run Pi Prime on let's say thread, I don't know how the cores are assigned here, but I'm pretty sure 22 has to be an E core. I mean, we'll know because it'll, okay, no, that's a P core. That's a P core. It's not running super giga slowly. Oh, there we go. Found an E core. Now, the thing is, Pi Prime is not a game, okay? But, like, that first loop is, like, more than 3 times slower than it was on a P core, or, like, that first step. And I think overall it's going to be, yeah. Yeah, so we're like, basically 3 times slower than the P core. Now this, I am, like, the thing is, I don't know enough about what Pi Prime is actually doing underneath, like what exactly the workload does. I know for sure it's very memory bottlenecked. But it does scale with CPU performance, as you can clearly see, because it's now 3 times slower, even though it's like admittedly it's connected to a very different cache, like blob, right? Like the E-cores share L2, if I'm not mistaken. But yeah, this is like, But like, I don't know, it could be using some like very like weird, like it could be doing some really like heavy math that like E-cores are specifically bad at that like games don't do. Right? Like that's the part I don't know. So it's like I don't know if like really really bad Pi Prime performance necessarily translates into gaming performance. It probably doesn't. But if it does, then I get like again I guess it'll depend on the game. What's funny with Arrow, like actually, can Oh no, I can't really pull that up easily just yet. So before I got incredibly tilted at the OC formula, I did manage to run some gaming benchmarks just with like 200S boost and stuff, which unfortunately I'm just going to have to rerun everything with this motherboard, or maybe the Gigabyte board. I don't know. Like, we'll see which one I decide to go with in the end. Because again, if the Gigabyte can run higher memory clocks, then like obviously I want to give the 270K the best chance possible. But at 5600 JDEC in Beyond All Reason, and this is specific to Beyond All Reason, okay? That's why I bring it up. The 270K Plus loses to the 7600X at 4800 JDEC. Not by much. It's very, very, very close, but it is slower, which is just insane. Now, in a bunch of other games, the 270K Plus does have an advantage. But yeah, even with like 200S boost, the 270K Plus and the OCF's 200S boost is better than the Tomahawk's 200S boost. Like it still loses to the 7600X with like 6000 CL30 and lazy memory timings, which admittedly is still going to be better than 200S boost timings. But like, yeah, that game like really hates Arrow Lake CPUs for some reason. Which is just like, yeah. And a bunch of the other games are actually just kind of fine on the... I should have just copied the columns over to each other. Why am I like this? Yeah, like some of the games like Arrow Lake takes a huge lead. Like Marvel Rivals, which to me always seemed like it might be memory bandwidth bottlenecked. Arrow Lake massively wins that. It also massively wins Cyberpunk, massively wins Riftbreaker. But then like CS2 is actually like still winning for Arrow Lake, but it's not winning as much as you might expect. Like I was kind of, yeah, expecting that like Arrow Lake would not be so close to a 7600X in freaking CS2 of all things. But then Beyond All Reason is just like uniquely very AMD biased. Which is just like, I don't get how that's possible. But yeah, that's one of the reasons why I've been like, I wonder if like we get a Zen 6 CPU that doesn't have a horrible memory bandwidth bottleneck, what that'll do. Because yeah, like there's a bunch of games where I'm like, yeah, I've always suspected they're memory bandwidth biased, and they're very, very like happy running on Arrow Lake, and not really that happy running on Ryzen CPUs. The thing is, Beyond All Reason is basically entirely single-threaded. At least, like, the performance-critical part of that game is entirely single-threaded. Worse on Arrow Lake than on 14900 KS unless you pump D2D and ring ratios. I would have expected most things to be worse on Arrow Lake than on Raptor Lake, to be completely honest. After PC back from sleep. So sleep has like a really weird, like sleep is weird. And so like it reinitializes the memory in a weird way. And if basically if the CPU designers didn't account for the fact that you could have overclocked memory, the way it resumes the memory from sleep is like, it just breaks. It used to be, like, I remember there was a period of time where sleep would just break straight up CPU overclocks. So like I literally don't have sleep enabled on any of my desktops ever because it used to be like a huge problem that if the system went to sleep, it wouldn't wake up properly. And this is before I got into memory overclocking. That was just like, I was running like DDR3 1600 CL9, but like I was overclocking the CPU and I was already like, okay, no more sleep because sleep caused weird problems. I don't use Hibernate. The computer is either off or it's on. None of this like keeping data sitting in the memory and then hoping that you can somehow like skip the boot procedure. So yeah, sleep being like a horrible non-functional mess on overclocked systems is just like a fact of life. At least to me, it always felt like that. And so I just don't bother trying to put anything to sleep if it's a desktop. Which, I guess it's not a very good approach to it, but like, wait, did I? Oh no, I'm an idiot. Definitely don't do that. Spawn thread for all tasks. Let's try that. So, yeah. And like, the thing is like, obviously it would be nice if sleep actually worked correctly, but like, I'm so used to it never freaking working that it's just like, nope. Sleep is for laptops and desktops. You just like, you either have them turned off or you have them turned on. Because if you let them go to sleep and you have an overclock, chances are it's going to break and it's going to be a pain. Getting a Z890 Apex for an existing 270K plus for CPU intensive gaming versus getting a 9850 X3D is a better option. Depending on what games you play, that 9850 X3D is going to be literally impossible to catch up to. Like, CS2, no chance. Like, absolutely no chance. At least, like, based on my testing, I can't see a world in which a Arrow Lake CPU could ever catch up to a 9850 X3D in CS2. Beyond All Reason is another one. Like, that's just like, yeah, that hates Arrow Lake, and it hates Arrow Lake so much. And on X3D chips, it runs like 20% or something crazy faster than on regular Ryzens, and like Arrow Lake is already struggling against regular Ryzens in that game. And so on an X3D chip, that game is just like very much not possible to catch up. But then like Cyberpunk, I think you can get pretty close. Marvel Rivals, I think you can get pretty close. I feel like more modern game engines that like use more memory bandwidth seem to run less badly on Arrow Lake. Also, the Apex is ludicrously expensive for Z890, and I'm not even sure it's that good. The thing is, I haven't had the chance to test any Asus Z890 boards yet. So I don't know. I think spending money, like if you already have a 270K plus, I would just use it with some budget motherboard is my personal opinion. Because, I know Intel, well, I think Intel has now acknowledged that like they are not capable of making a real high-end gaming CPU. Because the 270K is not that as far as I'm concerned. But like basically I specifically requested this motherboard from MSI because I messaged MSI, like I sent them an email where I was like, hey, do you have any Z890 motherboards that you would like me to test? And their first response was like, oh yeah, we have the very expensive Unify X, or the Ace, which is also extremely expensive. And my response was like, yeah, $600 motherboard for a $300 CPU doesn't really make any sense. Like, to me, it just doesn't. So, yeah. And speaking of the 9850X3D, like, as far as I'm concerned, you can run a 9850X3D on like a $150 motherboard. And you probably should, unless you have some very specific requirements. So, like, yeah, like, how much is the 9850X3D? Like, you could probably get your motherboard and 9850X3D or 9800X 3D for less than the price of an Apex. And I think that's a reasonable way to go. Because, yeah, the thing is, like, the really, really expensive motherboards, like, I like them. I think the, like, X870E Unify X is really cool. And I think the Z890 OC formula, if the power button worked, is really cool. And, you know, I want to test some, like, well, I'm not sure how much more Z890 I want to test, but, you know, it would be kind of interesting to test more boards. But, like, doubling the cost of the motherboard is not going to make the CPU performance move at all, basically. And so it's just like, yeah, this doesn't make sense. Okay, so the thing you need to understand about strong CPU cores is that basically everything inside the CPU exists just to hide how miserably slow RAM is. Okay? Why does your CPU have an L1 cache? Because L2 cache is slow. Why does it have an L2 cache? Because because L3 cache is slow. Why does L3 cache exist? Because RAM is really, really slow. And then you have things like, oh, out of order execution. Why do we have out of order execution? So that we can avoid the slowness of memory. Why do we have branch prediction? So we can avoid the slowness of memory. So basically, everything that makes a CPU faster is avoiding memory access. And the better your CPU is at avoiding memory access, the faster it is. And that's basically CPU progress for the last, I don't know how many years. Because, like, the whole, like, as far as I know, the logic of CPUs outpaced memory in terms of performance, like, before the year 2000. And so chip design has basically been, how do we avoid our incredibly slow memory for forever? So, yeah, like, I don't consider the X3D, I don't see it as a gimmick. It's the logical conclusion of how do we solve RAM being terrible without, like, making the CPU core gigantic, right? Because that's basically, like, the more advanced your branch prediction gets, the more, like all of the, like, extra logic you pack into the CPU to try avoid having to access the memory is like, yeah, the core gets huge. It pulls tons of power, and what do you get in the end? Slightly reduced memory access. And AMD's like, yeah, well, what if we just had more L3 cache? And didn't need to access the memory as often because of that. Now, obviously, there's scenarios where that completely falls apart, because, you know, if you're encoding a video, it doesn't fit in the L3 cache. So, or if you're, like, doing some 3D rendering work, that also doesn't fit in the L3 cache. But for gaming specifically, like, you know, bigger L3 cache is actually a really, really good way of solving the memory problem. Yeah, the 9950X3D2 doesn't have a bigger L3 cache. It's two 9850X3Ds, each with their own L3 cache. Like, that's why AMD, like, early on said, like, yeah, making a dual X3D CPU is pointless, because You can't like they're separate pools of L3 cache. You can't put them together. It's literally worse than multi-GPU setups. Why NVIDIA GPUs have a very big L2 cache and don't have an L3 cache? I don't really know enough about how GPUs work to explain that. But like the whole reason GPUs have a giant cache of any kind is because they want to avoid memory access. Okay, so I think this is tapped out with the extra like interconnect clocks right now, which is really annoying, like disappointing. I thought I would gain more, but it didn't. I guess we gotta push core clock. Yeah, like funnily enough, if you look at the trend in like cache levels for GPUs, it's basically the same thing as like CPUs, where it's just like more and more cache. And GPUs had it like easy for a while because GPUs, like you just need a lot, like they process a lot of data in parallel. So it's like, you know, like caching it didn't even make that much sense. But I guess now it does. And so NVIDIA GPUs just suddenly got really big L2 caches. I guess I technically didn't set the minimum ring ratio, but anyway, so I'm guessing the P-cores... What are they even running at? I didn't bother to check that. So we're going to save and reset. And I want to check what the ring, like what the cores are doing when Y-Cruncher is running. Yeah, but like I think the question he was asking is like why do you have like why would you have a big L2 instead of like a smaller L2 and a bigger L3? And that like I don't know. Yeah. I mean, I like to be fair, I don't even know enough about CPUs, but generally speaking, the trade-off with caches is that the bigger your cache gets, the slower it is. And the X3D chips are kind of cheating that as far as I know, because while there is a very slight... Actually, I'm not sure it's even an L3 cache penalty. It's like a memory penalty because it takes longer to search the cache before it tries to go to memory. So that's why like X3D chips, if you've ever seen like latency benchmarks on them, they're actually slightly worse on memory latency because they search the entire L3 cache before going off to memory. And so that takes a little bit longer. But as far as I know, the L3 cache itself isn't that much slower because it's like physically in the same, like, because it's 3-dimensional, it's not 2-dimensional. Like if they just made it like 3 times, if they made the cache like longer, it would be slower. But they just made it taller, and so it's not as much, like it didn't really get as slow as it otherwise would have. If I'm not mistaken. But yeah, like I don't know enough about chip design to really be an authority on this kind of thing. Okay, let's see. So if I run this, we get... Oh man, I keep getting screwed up how the cores are not all next to each other. Okay, 5.4, 5.4, 4.7 on the E cores. Okay. AMD has a very big L3 cache. I guess AMD has like a very different approach to their... Like, I just don't know enough. Because the thing is, if I'm not mistaken, GPUs at like the architecture level don't even run the same style instructions instructions. Like NVIDIA machine code is, or like NVIDIA assembly, which I don't know if that's a thing, but as far as I know, that would not be even remotely comparable to whatever AMD assembly is for their GPUs. I think 49 should work though, but obviously, you know, like it's a bit random. I'm gonna do the E-cores first because they're kind of more predictable. Different GPUs. It's even, oh yeah, because you have like very long instruction word, right? The old AMD GPUs. Then you have GCN. Then you have RDNA. As far as I know, they're each like fundamental, like well, I'm not sure if they're like fundamentally different, but they should be very different. And that like, and the whole point of the GPU driver is that it takes like common programming language, be that like DirectX, OpenGL, Vulkan, what else is there? That kind of thing. And then it translates it into whatever custom thing the GPU is actually running. Never know. 40. I think 49 will work. Like my 265KF doesn't complain about 49. It complains about 50 though. Also, the thing is, I currently have all the voltages set to auto, so I'm kind of hoping that the motherboard will just do like, or that the CPU will just send a higher vid request. GPU drives HLSL and compiles native binaries. Yeah, I don't know enough about GPUs. Whatever you say. Yeah, so that runs. I mean, right now it's running with like slow memory settings, but it runs. I should just lock in the memory timings at this point, probably. Is the 7700X3D4 on AM5? Yeah, it's a bit confusing. I mean, I guess I could take my 7800X3D and like slightly underclock it to see. But the thing is like, yeah, it's a weird. Well, the thing is, I wonder if there are, because I would assume that there are certain like games that are so extremely X3D biased that like it doesn't matter if the CPU is like half a gigahertz or actually a 7700 X3D. That's going to be like a gigahertz slower, isn't it? What's the spec on that chip? Max boost 4.5. Yeah, so it's like a gigahertz slower than a 9700X. But I think there might be like some games where like the X3D is going to be just like, yeah, even with a gigahertz less core clock, it's still going to be faster. Let's try more E-core clock. I kind of suspect Beyond All Reason is like that. Because Beyond All Reason on the 9850X3D, like the processing time is like with JDEC memory, the processing time is under 15 milliseconds. That's simulation, there's a middle step, and then the draw time as well, which the crazy thing about the draw time is you'd think that's just GPU processing time, but it's not. It scales with CPU performance. The 9850X3D has way shorter draw times than any of the other CPUs I tested. But anyway, so the 9850X3D runs that at JDEC in like 15 milliseconds on average. The 8600G at JDEC takes 30 milliseconds. The 7600X at JDEC takes about 25. The 270K at JDEC takes about 26 milliseconds. And so in a game like that, it's like, yeah, the 7600X isn't clocked that much lower than a 9850X3D, but in that game, it's like, what, like 10 milliseconds slower? It's like the 9850X3D is doing that processing in like almost half the time, right? So I think a 7700X3D in that same scenario would basically, like, obviously it wouldn't be a 9850X3D, but it, like, I feel like it would be probably still under 20 milliseconds, is my guess. I wonder what kind of temperatures we're getting. Oh, it's, what? How is it thermal throttling? And it's the E-cores that are getting like super duper stupid hot. See, one of the reasons I wonder what happens if you just ditch all the E-cores is because Arrow Lake is very temperature sensitive. I also ran my 265KF with the radiator outside. And like, it was crazy to me because like I put the radiator outside and the CPU suddenly clocks like 200 megahertz higher on everything. Which was like, wait, what? Intel should be shipping these with a chiller. And like, I didn't even need to raise the voltages or anything. It's like, oh yeah, chip is somewhat colder, clocks way better. Anyway, so there's a funky trick that you can do on Arrow Lake, where if you disable all of the silly safety features, you can basically bypass the DLVR, even though you can't officially bypass the DLVR. And then the performance, well, then the thermals get much better. Okay, that's already disabled. I need to disable all of this. And that's already disabled. Okay, we've got our lovely load line things going on again. Oh, I should have checked what voltage it's requesting. When it's running. So I'm gonna turn the E-cores down a notch and let's check. Is this CPU even faster than a 14900K when both are tuned? I have my doubts. I haven't tested that yet, because I've only very recently started doing gaming benchmarks. But like, that's probably the thing I'll test. I'm actually not sure if I'll test the 9700. I guess I should do the 14900K before I do the 9700X. Yeah, I'm expecting to see like 1.5 input voltage because those temperatures are crazy. I would imagine Forza Horizon 6 is probably pretty memory bandwidth biased. The hell? Wait, is that related to the system agent CEP? What? What? The thing about my 13th and 14th gen CPUs is that they don't see much runtime. So like they're basically in the same condition that they were in when I decided to stop testing them. Has a lot of physics. Yeah, so I would kind of imagine that it would be kind of bandwidth biased. Actually, in my experience, like it seems to me that a lot of modern games are pretty bandwidth biased in general. Because like I've been talking to somebody else who's been doing a lot of like memory testing with Ryzen CPUs. And in their and they keep telling me about like these games that they're testing that like, oh, it loves when you run like high FCLK, even like games that like prefer 2200 FCLK to 2000 FCLK if you're at like DDR5 8000, which is like at 8000 you would think like synchronized FCLK should basically always win, but apparently there's games that actually are so memory bandwidth biased that they like 2200 is better. And most of those games are like, oh yeah, that's really modern, like Unreal, like stuff that's on Unreal Engine, and yeah, like generally kind of modern games is what I remember, where it's like, oh yeah, super memory bandwidth biased. So that is interesting. I think that was IAC, like I think that was the CEP for the system agent. That is whack, though. Wait, can I turn the iGPU off? Or would I go to do that? Okay. Well, I can't find that. Anyway, hopefully SACEP fixes the instability. As far as I know, Intel blocked disabling the DLVR. Like if I try to run bypass mode on the OC formula, it just gets stuck at like 400 megahertz on the CPU. Ampinel Wire and WireView Pro 2. I think trying to force current balancing through the power connect, like from the like supplier side, is a bad idea, because what you're going to end up doing is you're going to lower the input voltage to the GPU. And the more imbalanced the current draw gets, the more you're going to lower the input voltage to the GPU. Right? Because the only way you can like try to balance the connector is by like adding more and more resistance to the pins that aren't out of whack. And so you're going to just end up with the GPU getting less and less voltage, which I think from a like from a stability perspective, that's probably not good. Like technically the voltage regulator might work better with a lower input voltage, but like as in like be more efficient because there's less of a like conversion step, but then you're also pulling in more current, and so you're like, well, technically I think NVIDIA GPUs enforce a current limit rather than a power limit, but like, yeah, so I don't know, like that just seems like not the best idea. Whereas just per pin like per pin current monitoring, that seems perfectly sensible to me. And having like a shutdown, like a thing to like shut the system down when it triggers. Nah, the Ampinel does tries to do current balancing. Also, I wouldn't bother, like, if you have a small current imbalance, like, balancing it is pointless. And if you have a big current imbalance, balancing it isn't possible, right? So, like, because, like, the thing is, even, like, yeah, like, the connector, like, even, like, the 6 pins and 8 pins, like, those aren't perfectly balanced ever either, right? It's just that the imbalance isn't a danger because it's too small to be dangerous. So like basically, if NVIDIA wanted to fix the 12-volt high power connectors, what they could do is they could just downrate it to 300 watts and require GPUs to have 2 of them. It's the same size as a single 8-pin. Like, just have more of the stupid connectors. And then personally, what I would do is I would subdivide that connector into 2 6, like on the board, I would treat that connector as 2 separate 6 pins. So then you can have fuses that actually freaking protect something. Because like with the current 12-volt high power connector, like there technically are 5090s and other 50 series GPUs that you can get that have fuses on the 12-volt high power connector. I don't think those fuses are going to do anything because you have like 70 amps worth of fuses there. They're not going to pop until something burnt a hole in the board anyway. Right? Like that's higher OC. Like that's such a high like current rating because the thing about fuses is they don't pop when you put 20 amps through them, or they do, but like if you have a 20 amp fuse, it doesn't pop at 20 amps, not quickly. So for it to pop quickly, you need to go quite a bit over that. It's like, yeah, so you have 70 amps of fuses. Like, yeah, that seems like it's really going to protect something. I really hope that was a capture card glitch and not like some kind of memory stability problem. I turned the CEP back on. Like, what the hell? I didn't touch the damn memories. Wait, I did raise the D2D clocks, didn't I? And I did raise the ring clock. So it's not completely impossible that one of those two things might be related to our sudden, unexplainable blue screen issue. Though page fault in non-paged area really should be a memory problem, not a... Right, yeah, because I raised the minimum ring ratio. Could I just pay you to overclock my RAM? No, because I don't want to be responsible for tech support. Yeah, that error, I know. Like, I'm like, you know, when I just saw that ring ratio setting, I was like, oh yeah, that would do it. D to D, yeah, it would make sense that D to D could cause page faults. Like, really anything that's, like, going out to memory could cause page faults. There was one more thing I wanted to tweak. Right, I wanted to turn off the CEP again. But 3.6 D to D is really low. Like, that could cause boot issues, but I can't see it causing stability problems. Would you put 4000 CL16 dual rank B die on a 5800 X3D or a 14600K? I would probably go 14600K for that. Like, that is actually one thing I really want to test with Arrow Lake is like DDR4 versus, well, versus everything, right? Like, that's like the way I've been doing the gaming overclock videos right now is like I gather all the data for one configuration and then we just and then I can just copy the results against each other, which is kind of cool. Man, the Intel curse is real. Honestly, I kind of wonder if a 14600K with dialed-in memory shouldn't just beat a 5800X 3D. Two X32, 6000, 8000. So very technically, I have seen dual rank Hynix setups running DDR5 8000 on Ryzen systems. I've tried I've tried messing with that myself. I got kind of close to having 7800 work. And there is also single rank Hynix 32 gig sticks. And as far as I know, those do clock really high, but their timings are trash. So, and I haven't had a chance to test any of those. Okay, well, I guess we're going to just have to lower the memory speed because I am... Okay, no, I am not going to accept the memory speed trade-off just yet. I'm going to literally turn everything up. What if I just put the ring ratio back to auto? What then, hey? Two by 24 it runs 8000 best. So funnily enough, I guess it might be I just don't have enough sample size for 24 gig sticks. Like on paper, 24 gig sticks should be easier to run, but I kind of feel like a lot of the motherboards might be like better tuned for A-die. So 2x16. Does Intel have a better memory controller? Would I notice better latency? So the issue is I don't actually play CS2. So the only thing I can judge CS2 performance off of is benchmarks. And the benchmarks say that the benchmarks I've done basically say that a 9850X3D is just faster than everything when it comes to CS2. And that's basically regardless of memory settings because it doesn't scale. Like CS2 especially doesn't scale on a 9850X3D because I have a sneaking suspicion the entire game is in the L3 cache. Or at least, like, not literally the entire game, because the game is like 50 gigs. But basically everything the game does is in the L3 cache. And so if you run it at JDEC, or you run it at 8400 CL34, or you run it at 6000 CL26, or 6400 CL26, the performance is the same, according to the benchmark. Because again, I don't play the game, and I'm not about to start playing it, because tactical shooters bore me out of my mind. Max 5800X3D gets only 240 lows. That's worse than Ryzen 7000 with tuned memory. Oh, well, I mean, it is also like Zen 3, so... What VSOC? For the 8400, I think I was running 1.1 or like 1.05 VSOC. 6000 and 6400, I think I was running 1.3 or 1.2. I don't remember right now. Well, 6000 it was probably pretty low and reasonable, and 6400 it was probably close to 1.3. But yeah, 204 in the Angel Dust bench, the 240 lows that's really low. It's like the 7600X. Yeah, like 6000 CL30 was getting like 270 on the 7600X for 1% lows. Now, 4800 JDEC was only getting 225, so... Yeah, and the 270K Plus with 200S boost was also getting about 270. But that's DDR5 8000 200S boost. Buying cheap DDR5 RAM and running an X3D chip in 111. You could run an X3D chip with freaking clear CMOS, and in most games it doesn't make a difference. $200S boost alone, yeah, it can. Unfortunately, if you get really, like, I don't know which part of it is unstable when that happens, because it's like both NGU and D2D clocks are pretty low, but I think, like, I would guess it would be NGU. Is there any chance I can pay? No. Like, I don't sell tech support. Especially for a game that I don't even play. Non-3D Zen 5, yeah. Unless you play very, very specific games like Beyond All Reason, even I'd honestly take a 250K plus. Like, to me, the 270K plus seems a little too expensive for what it is, because it's like, okay, you get 8 P cores instead of just 6, and you get 4 more E cores, but it costs like 50% more, and it's not 50% faster, and it's more annoying to cool. I guess you don't have to tune it though, right? Because your like core clocks are higher out of the box, so there's like, whereas with the, well, I mean, you don't have to tune a 250K plus, but it's like, you know, you're leaving more on the table with a 250K plus if you don't tune at least the P cores specifically for games. Okay, so now it works again. So what did I change? Right, I dropped the min ring clock, and I dropped D to D, if I'm not mistaken, right? Yeah. Yeah, LG 1851 motherboard prices are stupid. That's why I wanted to test this thing, because this isn't like super ridiculously expensive. But then you look at like well, to be fair, if you look at like a Crosshair versus a Maximus, the price is kind of equally stupid. So yeah, for Z890 personally, I'd be looking at like Gigabyte Elite boards, MSI Tomahawk because it has the postcode, which also it doesn't have the stupid power on bug as far as I can tell, which Gigabyte does have to some extent, and ASRock has to the extreme. Which boards do you like? So I like the B850M Force. I need to retest the MSI B850 ITX with the like now that I've had 8400 gear down mode off working on the Unify X, like I'm kind of wondering if I use that same combination of parts on the B850 ITX from MSI, is it going to do the same thing? Probably. And if it does, then it's like, okay, that's a very good board. I really wish I could say I really like the X870i Strix from Asus, but while the power delivery on that board is great, the memory overclocking is not. I haven't tried an Apex yet, but I think that's probably, like, I kind of suspect the X870 Apex is peak for AM5, but still haven't tried one. I did recently get an X670E Gene again, and I like it. It's very good. Doesn't quite have the same voltage regulation as the ITX board because it uses the cheaper capacitors, but yeah, and then I haven't tried a Gigabyte Tachyon, and I haven't even tried a Gigabyte 8-layer PCB. I have tried a Gigabyte 800 series 6-layer PCB, and it's pretty good. Like, it'll do DDR5 8000, and I think Gigabyte claims support like 8200, which I disagree with. I've tried a CPU that does 8300 on that board, and it did not do 8200 like at all. So, yeah, I don't know. Like maybe they use like an 8800 CPU to get it to do 8200, but an 8300 CPU does not do 8200 on that board. That's the X870. No, yeah, X870 Elite. All right, I wanted to check the voltages and then got rudely interrupted by everything falling apart in terms of stability. D to D, so D to D is die to die, and NGU is next gen, or no. I don't remember. Like the abbreviation makes sense, it's just weird. So B650 Tachyon is actually scuffed as hell. Like I tested that board with some more recent BIOSes, and like I don't know what Gigabyte did, but that board basically doesn't work. Next gen Encore. Yeah, so yeah. Yeah. So see that's actually a completely reasonable abbreviation. Not very descriptive, but reasonable. So I don't know, maybe Gigabyte fixed the B650 TAC, but like, or I broke it somehow through like handling, because like that board, like the last time I tried it, it was so unstable. Also, like one of so I already had I still have two B650 E Masters. So the first B650 E Master I got had like a production defect where it can't run all core AVX workloads. You try to run something like that and the VRM just shuts down. Like Cinebench will cause the VRM to shut down. So that board's just completely unusable. So Gigabyte sent me a second one that should be fixed. But recently I tried to run Prime 95 on it. Guess what happened? The VRM just shut down. Right? Like normally if you have a Ryzen motherboard crash, it'll like hang or it'll reset itself or it'll like there's like symptoms that a normal properly working motherboard will have. But yeah, this one, like the VRM just turns off. Like literally vCore voltage just goes to 0. Everything else on the motherboard is still running and there's no vCore. And it's just like I don't know if that's like a recent BIOS bug or if that's just like Prime 95 was always a problem and I just didn't run it until recently. Mind you, that's not small FFTs, that's large FFTs. So it's not even pulling that much current. And like, I am tilted. Mind you, it does that at freaking like 6,000. It's not even like at high memory clocks or anything. And I was really hoping, because I tested the X670 Aorus Elite at like DDR5 8000, and it was like, oh, this works, that's cool. It's one of the very few 600 series boards I have where that works. With a 9000 series CPU, not a 7000 series CPU, but still, I was like, okay, that's cool. Now let's go test that on some B650 boards. And yeah, like the master is like, oh, that doesn't want to run Prime 95 for whatever reason. It just turns off. And the B650 Tachyon is just like super mega scuffed. Like it's basic, like it's not shutting down, but it can't, like it's not stable at all. And I'm just like, what the hell happened? That was literally the first motherboard I ever got DDR5 8000 to work on. And now it's just like, yeah, it just doesn't work at all. I also retested the B650 Live Mixer, and I don't know what ASRock did, but their 2-to-1 mode is now worse than it was when it first got fixed. Because like I got 7600 working on that board at one point, and now it's like 7200 is a struggle. Which, yeah, like the state of BIOS support for like older motherboards is just, well, I'm not sure if it's all older motherboards, and the ASRock boards didn't seem that good at the time, but I don't know. Yeah, just kind of frustrating. Anyway, I wanted to check the voltages because I'm expecting them to be kind of... Where do we have core voltage? CPU I/O, that's useless. V-core. It's at 1.4. That's not that crazy high. But the chip is hitting 105 degrees in throttling, and it's the E-cores, because of course it's the E-cores. Little flamethrowers. Whatever I do, JDEC feels best. Well, then just run JDEC. Like, I tested CS2 on the 9850X3D, and I literally could not, like, or I shouldn't say I couldn't measure a difference, but the biggest difference I measured was like 3%, which is not perceptible. So if you find that it runs better at JDEC, just run it at JDEC. Because it's like, it's not like, even if you bend over backwards, it's not going to get like 10% faster. PCIe errors next sentence. If I have PCIe errors, yeah, I don't know. Infinity Fabric retransmit errors you can definitely feel, but you can probably also just hear them more so than feel them, because they should cut audio really hard. Not using a riser? Yeah, that doesn't mean the GPU can't be making like bad contact with the PCIe slot, or like one thing I wondered about is if you put a metal plate too close to the PCIe traces on the motherboard, if that's potentially gonna mess with them. 2060. Oh, that is very weird. Because that's what, Gen 4, isn't it? Yeah. Anyway, I turned off all the CPU undervolting stuff, right? Okay, so now what we're going to do oh man, MSI actually has this way... Yeah, I think this is way tidier than what ASRock has. What time is it? Oh, it's after midnight. I can probably open the window without getting an insect invasion. Bruh. The light will attract them? Yeah, but I already tried this during the test stream with the 7600X. So funnily enough, a lot of AM5 motherboards will default the Infinity Fabric to 2000 even at JDEC. which they probably shouldn't be doing, but they do. Maybe get window nets. Yes, that is the plan. But the plan has not been... Wait, no. That shouldn't be it. Maybe the E-cores need more voltage, but like 1.2 volts is already a lot of E-core voltage. Yeah, no, but I'm used to use, like, on the 265KF, I think I was using, like, 1.25 for, like, 5 gigahertz, not 4.9. Also, no AC? Yeah, not, like, the place didn't come with any AC, and I certainly haven't bought any yet. The issue is, I don't want it doing anything. Okay, I gotta say, I am actually, and this is really disappointing to say, but I am impressed that so far I haven't had to unplug the power supply a single time during this stream. Now, admittedly, I've not been as, I've not been testing settings as quickly as I would be if I was doing this alone, so chances are I might have stumbled across the magical combination of power button no longer works sooner. But if we were on the OCF, I would have already not been able to get, like, the system to turn on at least once. I have had a theory that, like, the interconnects on these Arrow Lake CPUs have some kind of, like, training procedure, and if that goes wrong, the system just stops working. That's why it'll, like, sometimes, like, it'll work, and then sometimes it'll just stop working. Hey, at least this time the power button is like, the board knows how to turn on and off. Like, my theory for why there's, like, such a problem with some boards not wanting to turn on is the VNN AON rail. As far as I know, the AON stands for always on, and it runs off of 5-volt standby. So I have a theory that the reason why this issue exists with Arrow Lake motherboards is specifically because of whatever the VNN AON rail does. What do you think I should do? Are PCIe errors important and dangerous? As far as I know, PCIe does have error correction. But I would also say you probably shouldn't be getting PCIe errors, but... I don't know what you can do about them. I mean, I guess you could try drop the link speed to Gen 3. That seems like a bad idea from a performance perspective. Hey, look at that. If you don't let Intel run the CPU at their own voltage settings, it stops overheating constantly. Okay, so it probably looks like I have the clock stretching stuff disabled. And I guess I'll just have to accept that like high D to D is not gonna be cooperative. Because I swear I noticed like a similar issue with when testing the 265KF, or maybe actually I swear I mentioned something like that in the 250K plus video. Or like I was testing it with like 38 D to D, and then that just randomly stopped working, and so I had to test at 36. Yeah. Huh. Okay, so wait, what? E-cores? Yeah, from my testing on the 250K plus, it looks like pushing the D to D as high as it goes does not really make a ton of sense. Because like I literally tested, what was it, like yeah, I went from like the stock 39, 30, 32 to 43, 38, 34. And that made like 3% performance difference on average. Right? Which is like, I don't know. Do you really want to put up with a system that like struggles with turning on sometimes, randomly seems to lose stability? Though right now it looks like maybe this is an E-core issue, because like I raised the E-core clock and the stability went right back to hell, so... So I tested the 265KF a lot more than this chip, and on that chip it didn't seem to me like the ring clock doesn't really scale with voltage. Okay, this is... getting kinda cursed. Intel and making CPUs that don't have memory issues. Okay, no, actually I take that back. DDR5 is just straight up a mistake. Because, like, let's be fair, even AMD CPUs, the memory situation, and I'm not talking about the bandwidth, pretty scuffed. Okay, I'll just run the ring at 40. I'm done with it. Like at some point, like it's got to like start working, right? Like. It's your capture card of choice. Right now I'm using a AverMedia Live Gamer Duo or something? Yeah, AverMedia Live Gamer Duo, so that I can have the camera and the system feed into one capture card instead of having multiple capture cards. I do have one complaint for this capture card, which is that because it doesn't default to 1080p, or because it's not limited to 1080p, it's like a 4K capture card. Windows, like, it basically, yeah, like Windows and the colors are like scuffed. It's like a combination of like Windows seeing like a 4K like receiver, and so yeah, it's just so stupid. Though, funnily enough, even my old Elgato Camlink Pro, which is 4 1080p inputs, one of the inputs has like scuffed colors on it as well. But it looks sharper. Also, I tried some like some of those super cheap like USB capture cards, and those those just like they're the colors are just giga scuffed and you can't fix them. On this thing, like right now the colors look correct, the text mostly looks correct. Like this, I think. Wait, let me just pop this out so I can see. Why? Like, what did I even do? Like, what do you mean you're just gonna crash like that? Like, and people wonder why. Like, somebody earlier was like complaining, like, "Oh, Buildzoid likes AM5 too much." Yeah, because it works. I'm sorry for liking a platform that doesn't freaking just randomly throw a fit because it was turned on for too long. Like, what is it even complaining about now? Like, we're... Do not the interconnect. I mean, I guess I should have set VN and AON to auto if I set all the stupid clocks back to auto. Like, Ryzen has, like, issues. It just doesn't have issues like this. You know, it has issues like, oh, if you let the CPU retrain the memory when it's too cold, it stops working. But that is a very, like, I mean, at the time I didn't really realize, like, why exactly it was doing that, but then it's like, oh yeah, but you can just turn on memory context restore and it doesn't do that anymore. Get a fix for the PCIe issues? I would assume you probably need like a motherboard replacement, is my guess. Because like, unless the like, I mean, I guess like the GPU could be damaged and that could cause the errors, but alternatively, there's like the motherboard is an issue. So I don't know, like maybe find a PC store and ask them if they could like test your GPU for you or something. And if it's still doing it on their system, then GPU problem. If it's not doing it on their system, then you've got a motherboard problem. Am I imagining things, or is the text actually like kind of scuffed? Because I've like I have a source projector open right now. Yeah, no, the text is kind of scuffed. Oh well, capture card things. Yeah, there's like colorful fringing around stuff. Oh well. Like, it's just so stupid how, like, right now the capture card options are like, oh, you can have 4K or you can have, like, you can have, yeah, like, most of the, like, higher end capture cards are 4K, and then you have, like, the old, like, the cheap 1080p ones, and the cheap 1080p ones are always scuffed colors, and the 4K ones require, like, a whole bunch of settings fiddling to get, like, text to not fringe. So I wasn't imagining that. And like part of the issue is Windows itself. See if I can fix it. Because if I remember correctly, it was something I was doing in the freaking NVIDIA control panel that did it. Oh no, that made it worse? Maybe? I don't know. I guess one other issue is that I'm technically not looking at it at 1080p native right now, so makes it kind of hard to judge if it's it's like getting scaled properly. I think, okay, I still think the 140 hertz looks best. Yeah, keep that, whatever. Okay, what did I do to the core voltages? V core. Okay, we're at 1.35 and it dips to about 1.33. Okay. Mind you, I'm pretty sure this measurement is from the CPU socket, so probably not super accurate. And now CPU temperatures are maxing out at 92. TCWL minus equals TCL minus 2 is more stable than TCL equals TCWL. So TCWL being 2 lower than TCL is like JDEC spec for how that's supposed to be set up. And I guess there's some like weird thing going on with the memory training. Okay, let's do all the memory tweaks again. Oh, hell no. Changing command rate in the operating system is like not a good idea. What I do find interesting is how the different motherboard vendors like have very like a really different approach to auto timings. Like MSI over here, you know, we have XMP enabled and they're just running or yeah, like this is XMP enabled except I loosened out the primaries and raised the frequency and all the sub timings are just JDEC basically. Meanwhile, on ASRock, like TREFI X9, they just maxed that out. Refresh interval, they set it to 32,000. I think they even slightly lower the TRFCs and like, yeah, so interesting. Which basically means if you're testing like memory tuning, it's like depending on what motherboard you have, it'll do more or less. Right? Because like some motherboards will become like pre-tuned by the manufacturer. Okay, 14.4. Now, if I want to get top 100, which requires a 14.1, which we're very far away from right now. But a 14.413 is actually not that bad. That is 112. But if I run it with high priority. Are you going to do any BCL KOC on this? I did consider that. Depends on how cooperative the P cores are with raising core clock. Because I think Refresh Arrow Lake actually fixed this, but on my 265KF, trying to raise the P core clock is an experience. Because you'll punch in a core ratio, and then you'll run a benchmark, and you'll see that the cores are very much not running at that core ratio. And the only way to work around that I've found is to run like a lower ratio than the max all-core turbo and then using BCLK. Which is a similar bug that like Raptor Lake has for AVX ratios. Like if you set the AVX offset on Raptor Lake to 0 and you actually run an AVX workload, it will not run your max core ratio. Also, at this point, I am actually going to punch in a few of the timings for realsies. So that I don't have to keep resetting everything up every time we go into the OS. I am not a fan of this timing order. Like, what is this? Like, why is TRFC2 over here, and then TRFC per bank, and refresh interval here? Like, these three like, the refresh timings should be their own block, as far as I'm concerned. They should not be separate. They're all parts of the same thing. You know, I had a funny realization about 2-to-1 mode on Ryzen CPUs is like, as you go higher and higher in 2-to-1 mode, your refresh interval being maxed out at 65,000 is progressively increasing the inavailability of the memory. Which isn't really that big a deal on like the Ryzen CPUs, but on the APU, I think, where you're like at DDR5 9600 potentially, right? Well, at DDR5 9600 compared to DDR5 6000, the refresh interval is now way shorter and your TRFC is actually significantly higher. So like your percent of available clock cycles spent refreshing is actually like I think it's basically the percent difference in the memory in the clock that it's like, actually I think it's worse than that. I can't do that in my head, but it's like, yeah, it's like it eats into the refresh interval quite a bit. Or like refresh, like you spend more time refreshing than like you'd like to. Anyway, by the way, these two timings on Intel CPUs, no, these two. Wait, what? Oh, these two, yeah. These two timings don't exist, but I'm setting them because what I'm not going to do is I'm not going to set this, and I'm not going to set that. I'm going to set the ones up top, and the motherboard is going to calculate the correct value for these two for me. And generally speaking, the motherboards do this correctly. There's other timings which they just kind of do weird stuff with if you let them do it themselves. But those two are like, you can trust the motherboard, I'd say. Yeah, also why, like, TREFI X9 should probably be next to TREFI. So I gotta say, I prefer how ASRock lays out their BIOS in terms of timing layout. VTT ODT, that is, what on earth is that? DDR5 doesn't have a VTT rail, it's just ground and VDD. Q. Um, 'kay, we're just gonna set our read to recharge down here then. You know, one day being able to talk to whoever, like, sets up the memory timing registers for Intel CPUs would be very interesting. Like, a lot of what you have is like, man, why, like, it just doesn't make a ton of sense. Okay, this should be fine. Oh, and I wanted to raise the P-core clocks this time. Let's see, 55. %33% worse is about the number you were trying to calculate. Yeah, that seems correct. When 1T? I don't know, we might try that at like 6,000. I've actually been really tempted to try 1T command rate because like MSI has the tabbed memory traces on the command address bus, but like I've been baited it by 1T, like whispers of 1T working well on the OCF already, where somebody was like, oh yeah, OCF does 1T super easy, and so I tried 1T. It did not work, like at all. I must be holding all my Intel CPUs wrong. Because for some reason, my experiences with them just do not match anybody else's. Okay, let's see if it actually holds 5.5 gigahertz, because that was like an issue with my 265KF. Huh, it does. Oh wait, nope, that's dropping to 5.2. Wait, what? What? I'm sorry. Okay, can somebody explain to me why everybody about when it comes to Arrow Lake, they're always like, oh, the E-cores are great, you can clock the E-cores, and then you're like, I guess Cinebench score gets like higher. And then it's like, I raised the P-core clock by what? 200 megahertz? And it knocked off like 400 milliseconds. More, what 400 milliseconds? We're down in the 13s. Like, we're at mid 13s from raising the P-cores by 0.2. Like, I was like, oh, it would be kind of cool to get top 100. Well, I'm in the top 79. 13.5. Well, now I'm in the top 77. I'm so glad I didn't like bench my 13th, 14th gen chips to like really good scores, because now it's like now I have an excuse to run this thing. Because it's like a real issue is like, oh, with well, like, I mean, it's not really a real issue, but like, oh yeah, no, with the 245 is like, I have good scores with like 14600K, I think, or something. Okay, 1488. Okay, that didn't actually push me anywhere, but easy 50 points, which I actually like. I would I would like to get back up into the top 100 on hardware bot at a minimum, because quite frankly, it's kind of embarrassing that I run a YouTube channel like this and I'm not in the top 100. And especially with how much hardware I have, it's like, dude, how can you not be top 100? So yeah, but the thing is, for me to like gain points, well, if I like, it would be really easy if I just went and bought a 5090, but I still think buying a 5090 would be really, really stupid. But the thing is like my lowest global points is 35 points. So if I want points now to go up in the rankings, I need scores that are like at least 50 points, or it basically doesn't do anything. Anyway, this is a 50 pointer. Oh, and I guess for those who don't know the context, so here's my hardware bot profile. I'm currently top 126. I actually was a little bit higher up earlier this year because I benched the 9900X and the 265KF. Like, I specifically bought the 265KF because it's a 20-core CPU. So, yeah, see? Right there. 50 pointer. Like, that was one of the reasons I wanted that chip. Also, I was excited for the 250K plus because it's like, oh, it's an 18 core. It's going to be great at getting like 18 core scores. Yeah, about the whole like 18 core thing. So, yeah, it's actually good at Cinebench because it has a lot of Cinebench accelerators on it. But like, if you're like, oh, maybe it's good at 7-zip. Not really. I mean, it's not that bad. Apparently wait, did I not run 7-zip on this? Or did I run it like extra bad? Well, I mean, this is 6.6 gigahertz, so where's mine? Oh, I didn't run it. Okay, good. So yeah, I should maybe run that, but like, so yeah, so this is, yeah, but he's only getting 20 points for that. Oh, that's why I didn't run it, because it ain't worth it. So yeah, I was like really hoping the 250K plus would just like wipe the floor with a bunch of 18 core records. It can't. It really, really can't. So yeah, anyway, I already ran Cinebench on the 270K plus because I think Cinebench is a bit boring as far as like tuning goes, because it's like, you know, I mean, that's not a great score, but like the thing is for Cinebench, it's just more cooling. Like this, there's no memory tweaking, it's just more gigahertz equals more better. I mean, there are some tweaks, so I'm guessing, well, yeah, like I have a like I'm running 5.7, and this is a 5.7, that's a 5.7, 5.8. If we look at that score, what do I have? I'm running what? 5.7 on the P cores, yeah, and 5 gigahertz on the E cores. And the thing is hitting like 94 degrees Celsius, and Arrow Lake is temperature sensitive, so it's not gonna get better than that, I don't think. And if I look at like this looks like a really good score because it's like five, like you know, it's like, oh, but he's running 5.7. Yeah, but I'm gonna guess. Yeah, that's 5.3 on the E cores, right? Like it's my I'm like that's 5.3 on the E cores. Like, yeah, of course it's gonna get a higher score. The cores are clocked 300 megahertz higher. So Cinebench, hella boring. Right? It's literally just like whoever has the highest core clocks wins. And so I didn't really see a reason to like save that for a live stream because it was just going to be like, well, I've run out of cooling. I guess we're done here. Anyway, once I get the chiller, like, well, more like it's not get the chiller working. Once I verify that the chiller still works, which it probably does, I do want to rerun Cinebench and all that stuff as well as the 250K plus. But this room still isn't like done in terms of furniture, so. Anyway, but yeah, so the issue is like my lowest global points is 35. And so if like I want more points, I need scores that get lots of points. And the reason I said like, oh, if I had a 5090, life would be very easy. Let's say which one of these gets, I think Port Royal. Well, I mean, oh, it's not really a good one. I guess Firestrike. I think it's Firestrike Extreme that gets globals right now. Yeah. So this gets global points. And if I take even the slowest 5090 score, okay, maybe not this one. That still gets 37 points. Right? Which I don't know what they're doing here. They're running it on a 5000 series. Oh, dude, that's got to be so CPU bottlenecked. Right? So basically, if I had a 5090, even like a mediocre, like, okay, let's say I get into the top half of 5090 scores. Actually, that's still below the top half. Like, that's a 50 pointer right there. So, and honestly, I'm kind of annoyed about how, like, on HardwareBot right now, the GPU benchmarking scene is basically, like, as far as globals are concerned, it's just like have a 5090 and win. Whereas, like, the CPU benchmarks are all divided by core counts. So if you look at, like, Cinebench, right, you have Cinebench 1 core, 2 core, 3 core, 4 core, right? So, like, quad core Cinebench actually gets kind of, yeah, like, it gets big points. And you run it on a literal freaking laptop CPU that's modded to run on a real motherboard, which is kind of cool, actually. Like, yeah, that is actually kind of cool. That's a cool score. I wish we could actually see the system, but yeah. But yeah, in GPU land, it's basically have a 5090 or get, like, you know, or like no points, which I think is super lame. Because the GPU benchmarks, as far as I'm concerned, are much more interesting to actually run. Any 6000 Pro whales on HardwareBot? Not yet. And I'm surprised that there isn't, but I think HardwareBot is kind of... Oh wait, no, there is a couple. There is Firestrike Extreme. Yeah, but they're running it with a 9950X and still getting like 48 points on, yeah, a bone stock RTX 6000. Which, as far as I know, that GPU is overclockable. Like, it's not locked down. Anyway, let's see if we can go higher. You need a high X-bar BIOS? Does the X-bar make that much of a difference on the 5090s? Because like when I was testing a bunch of BIOSes on the 5080, the like highest crossbar BIOS I had, like I guess it wasn't that much higher than the other ones. So now he doesn't have 30K in GPUs to bin. He was offered to bin them. They weren't his. I mean, my daily system doesn't have any PCIe errors. Like I have hardware info running all the time. And yeah, I like if the PCIe errors show up in the like Windows hardware error reporting, I have none in like 335 hours of uptime. That's all. The score didn't go up as much as I thought it would. Wait, where do you see the PCIe errors? Because I'm like trying to find anything that says... Oh wait, no, I have like 19 NACs sent and like 30,000 recovery counts. But no lane errors. I think the recovery count is like the GPU like reinitializing or something. Yeah, like that's a NAC is like a non-acknowledgement of something. And I have 19 bad TLPs, but that lines up with the NACs. So, I don't know. I've not really noticed any issues with my system as far as like the GPU goes. Okay, so now we've got a 13.426. Okay, well that puts me at 75th. And what I kind of want to try is like drop the core ratios and use BCLK instead to get similar frequencies, because that might perform better. And it's not because we're gonna like, because on Arrow Lake you can actually run BCLK only to the cores. It actually looks like the frequencies are holding properly. It doesn't look like it. Oh wait, I have it in high priority, so maybe hardware info wasn't updating properly. But yeah, because on the 265KF, I was super annoyed when benching like Cinebench or something, because I could I'd be raising the core ratio, and at some point, the score would just drop, and it was like the CPU just decided, well, I'm not gonna boost anymore. And I'm like, what do you mean you're not gonna boost anymore? And the CPU is just like, well, I'm just gonna run at 5.2. And I'm like, yeah, but I set you to 5.5. No, I'm running at 5.2. And so that was that. It was stuck at 5.2, and the only way to fix that was to like reboot the system and then like try all over again. And modern hardware, everybody. Well, I'm not noticing any insects. The window is still open. If I'm not mistaken, this doesn't even affect memory clock, which is really cool. It might affect the ring and uncore clocks, but they're low enough, I think. CPU-based clock. Let's try just 101. What? Now this chiller has like a temperature controller, and it should go down to minus 20 degrees Celsius, which is like it's not like that's not dew point, that's ice. That's ice on absolutely everything. Like I'm gonna be prepping it like when I run stuff on that chiller, I'm gonna be prepping it like I'm running it on dry ice. Though the one like at minus 20C, I think like memory chips and well, the VRM on some GPUs is always a problem, so that's not even like except maybe on LN2 it wouldn't be. Okay, so I do remember correctly, it does juice the ring, but not the memory, which is so weird to look at. Dude, that is speed. I'm apparently like rivaling 14900 KS's on liquid nitrogen at this point. I'm still way behind a bunch of 270K plus scores though. Okay. How many points would be like, I mean, a 60 pointer would be really cool, but what would that take? That would take 5750 on the core. And maybe better memory settings. Oh, and 5.1 on the E-cores. I think at 1.25 that should run. Yeah, but the 60 pointer I'm looking at, that's 1.26 for 5.15 on the E-cores, which like I think is actually really good for E-core clocks for that voltage. Like I think that's above average. Also, apparently that chip was only hitting 80 degrees Celsius, which I'm not hitting 80. I'm hitting 90. I mean, I do still have headroom to lower the input voltage, so that might be one way I could try catch up. Oh no. That apparently will not run. So I guess I'm going to drop the BCLK, lower the input voltage, and yeah, see what happens. If you run a positive pressure setup, then like the ceiling doesn't matter that much. Like if you're if you're pushing like dry air in to the box, then yeah, like you don't have to worry about the seal quality too much. You know what? I feel like just skipping towards pretty close to what the CPU probably maxes out at. Now, the problem with what I did is we don't know if it's the E cores or the P cores crashing. I think it's more likely that it's the P cores right now, but I could be wrong about that. I'm dropping the voltage just because I don't want them adding unnecessary heat. Well, apparently these E-cores are trash. This is the second CPU I have where I'm like, yeah, where the E-cores are like really not very good. Oh well, we can shove more voltage into them. That will hopefully fix it. So the VDDP voltage and MISC voltage don't, like, as far as I know, they shouldn't have anything to do with PCIe. Yeah, SoC voltage might do something. I mean, you could try run your system at JDEC and check if the errors go away, but like my daily system runs on JDEC and it still has the errors, so I kind of suspect those errors might just be a thing with NVIDIA GPUs. Because, like, the thing is like, when something is designed to recover from, like, soft errors, it's like, yeah, well, you know, it, like, to me, in certain scenarios, that's just like, yeah, we accept that there's going to be errors, and it'll just function in spite of them. Right? Like, DDR5 has the on-die error correction, where it's basically the manufacturer's going, yeah, so we can't actually guarantee that the data is going to stay properly within the memory chip, so we're just going to build error correction into it so that the data is, like, we can keep the data anyway. Okay, so apparently these E-cores really are weak, which really doesn't surprise me because that's been like a consistent thing in my experience with Arrow Lake is like weak E-cores. Nah, I have a sneaking suspicion it might be an NVIDIA GPU thing, because I feel like at some point I saw an article about how NVIDIA GPUs are like misusing like some feature of PCIe or something. And it was causing issues for some server host, like for somebody running some server where it's like they couldn't reinitialize the GPU or something. The E-cores do not have fractional multipliers, as far as I know. Or more like Intel CPUs do not have fractional multipliers, as far as I know. I kind of wonder if the E-cores being like bad clocking is because they run so freaking hot. Hey, 13.296. So now, with any luck, I'll be able to run 101 BCLK and it'll work. Did you see about Expo ultra low latency? Yes, I've already heard about it a while ago. I'm pretty excited to see what it actually does, because from what I've been told, it basically preloads something that looks vaguely similar to my easy timings. Have you tried like watching the error count while running Fortnite to see if like it's causing a lot more errors to show up? Nah, like if like we'll see. I don't like I'm honestly expecting that the AMD ultra low latency thing is actually just gonna make all of my custom memory tuning kind of pointless. Oh, well, the Fortnite, yeah, I don't know why it would be causing so many more errors then. It was like maybe use a lot of VRAM or something. Well, I think the P cores are now overrun. Like I said, it should actually load up a set of timings that looks vaguely similar to my easy timings. As for the new timings that are now getting added to the AMD OC menu, I'm not sure if that might not be like future feature support. Because technically all those timings you just listed off are already controlled by existing settings in the BIOS. How would you... Nah, I'm just going to stick to all core. I mean, I guess... Oh. Wait, how the hell does this work? Wait, oh, wait. It's subtracting. Yeah, I don't like this. I'm not using that. Let's just see if fixed mode maybe doesn't give me a bit more performance. And that made everything way worse. Oh, insect spotted. And it's gone. Well, that sucks. Luckily, it's not big insect. It's just like a little fruit fly looking thing. Which I guess could be a mosquito, in which case I'm in for a really rough night, potentially. Because I am a mosquito magnet. Okay, well, I guess I'll close the window. Okay, well, let's put the CPU ratio mode back to dynamic, because apparently fixed mode is gigascuffed. So I have an idea. 101, and I'm like wondering if maybe I don't have a little bit of thermal headroom on the P cores, so we could maybe run them at a bit more voltage. Maybe, just maybe, that'll make them pass a 5.75. It's pretty funny. Oh yeah, the 8 gigabyte, yeah, the dual rank 16 gigs Hynix sticks. I'd really like to test some of those, because theoretically they should do extremely low TRFCs. And clock like garbage because they're dual rank. Okay, nope, it's thermally maxed out. Okay, yeah, I need to finish sorting out the furniture situation in this room, which involves moving a great big freaking couch. What? Yeah, no, like the couch is still here. Like the issue is if I just move the couch, this room will acoustically go to hell. Um so right now it's basically acting as a giant sound dampener, and so it's like basically this room, like I need all the furniture that's going to go in this room ready so that when I move the couch, I can just move the furniture in and the room is still like tolerable to be in. Because like my bedroom is mostly bare walls still, and boy, the acoustics suck in there. So bad. It's been like 9 months. Yeah, well, that's like like, what do you expect me to do about a couch? And like, it's not that much of an immediate issue. So it's like, yeah, I can still produce content with the couch in behind me. Um, so it's like, it's not like basically if I don't need to solve something right now, I'm not solving it. Yeah, but like technically it's not my couch, it's like well, I mean, now it's my couch for realsies. um so yeah, I guess I could just get rid of it. Actually, doesn't mem tweak it like, yeah, it auto corrects to max value. Maybe too much refresh interval? Apparently the top score is using interleave NUMA nodes. There we go. Yeah, I think I'll settle for that for now. Because what is that? Yeah, that's like 53 points. Time to save the score. Let's see if I can... Yeah, I should be able to fit everything. So that is top 66. Got CPU, motherboard, memory. Yep. And now we're gonna I'm still gonna try to push it a little bit higher by just like killing Windows Explorer and rerunning it a bunch. Wait, no. Really? Okay, you know what? I might set up the big room fan and open the door again to try cool this test bench. One issue with my genius idea, I'm sitting in between the fan and the test bench. So far most of the cooling is just me. Damn it, that is tied with 65th place. It just occurred to me, I could just plug the fans into the 100% fan speed hub. Nah, you just need to rerun the benchmark a bunch. No need to make it go any faster. I'm gonna shield myself with the chair. Oh, that's already pinned, isn't it? I wonder if I kept rerunning it, it might even still get like a little bit more faster. Like for some benchmarks, it really is just a matter of running them a bunch of times to get the top score. Like Cinebench is kind of notorious. Like, yeah, like there was a period of time where everybody was benching locked Intel CPUs for one of the Cinebench categories, and it was basically just like because everybody was like, these were locked CPUs, right? So everybody's running the same core clock. Everybody's running basically the same memory. Like, and also it's Cinebench. It doesn't really care about your memory settings that much. And so everybody was basically running the exact same settings. And the only way to get a top score was to just rerun it over and over and over again. Fun. Anyway, so that's that, and I'll just rerun it again. Wait, no, not that. Getting blasted by the fan is actually very distracting. Room temperature is now down to 23 degrees Celsius. Hey, that's 64th place. Huh. Thing is, I don't know if this version of CPU-Z... Oh no, it is opening the right version. Okay. I mean, I still need memtweak it though. I mean, I don't need it, but I want it. Like, I always think it's kind of lame. Like, we have this program that can show all the memory timings, and like, I guess that a lot of people are like, oh, my memory timings are too special, they need to be kept secret. But like, personally, I don't care. Well, I think I'll stop here. Yeah, it's a Cooler Master Atmos 360. Yeah. Anyway, I think I'll stop here, both in terms of tuning the benchmark. Like, technically, what I could still try at this point is, like, raise the memory VDD voltage, and then maybe, well, definitely I could lower cast latency, but it's not going to make a huge difference. And that's kind of the only thing I could still do, because, like, the other thing, like, it would be nice to be able to do is run higher memory clocks, but I don't know, like, we tried that at the start of the stream, and that was not going very well at all. So, yeah. Anyway, the main thing I wanted to do is, like, one, I wanted to get some points on Hardware Bot, and two, I wanted to just get a feel for this motherboard. And I think Y-Cruncher is one of the better tests for that, because, you know, it pulls a decent amount of power. It's pretty heavy on the memory stability. So it like kind of tests everything all at once, and you don't really have to do much. Actually, wait a minute. It just occurred to me. I did also want to run the other Y-Cruncher categories. How many points do those get? Right, so we just ran 1 billion, which gets, I think 5 billion doesn't. Does 5 billion get globals? Oh, it does. Ah, but it doesn't get many globals. Yeah, like... And it's going to take a minute to run. So we're going to have to definitely drop the peak. Well, yeah, I guess I could run it at like... I mean, I think I'd probably just have to turn down the P cores a bit and then run it. Because the system isn't really unstable. And like a 5.5 run is already getting 42 points, so a 5.6 run. I mean, you know, like I said, ideally I want to get like 50 plus points per score, but points are points. So we're gonna quickly, actually, you know what? We're gonna try 2.5 billion on the settings I'm at right now, because, like, who knows? Maybe it'll work. Maybe it'll pass. And 2.5 B is going to get more, like, decent points just because it's 2.5 billion, so it's more, like, it's shorter, so it's more popular. So if I could run it at a full tilt like this, that would be kind of nice. Actually, I'm not sure if it's that much more popular, but... Yeah, that's more popular. So I might get like a 50-pointer or something. Damn, that's actually way better than I thought. What? I mean, it is a 50-pointer, but I was like, you know, I was looking at these scores and I was like, oh, I'll get like a low 50-pointer. Nope. We're in... Where are we? This is a 3764. Yeah, so like this is actually like, well, it obviously it's higher ranked than my 1 billion score, but like it's 56th place. Oh, that's cool. That's actually really cool. That's like 55 points. Man, now I'm kind of tempted, like, oh, if I ran this if I ran the CPU on a motherboard where I could, like, well, I'm not sure if it's, I still don't know if it's the CPU or the motherboard that's limiting the memory clock so much with this one. Because, I kind of want to try rerunning it with higher priority, but like... what's the worst that can happen? It can crash. It only takes 30 seconds to run, so... I will say the fans that Cooler Master used on this AIO are really high-pitched. Like a kind of buzzy sound to them. Yeah, that's the same damn score. It's actually slightly slower. Okay, well, let's try 5B then. I'm still surprised why Cruncher has like this situation where it's like, okay, I'm gonna turn the big fan back on for this because this is gonna be a minute of load, and the 1 billion runs were like crashing after some, like if I ran a bunch of them after one after another, they'd sometimes crash. Okay, so that's what, 2 minutes? No, 1 minute, 24 seconds? Okay, so only like 41 points. Not great. Oh well. I'm not gonna bother with memtweak it for this one, though. I do think I might run 7-zip. Because that is pretty memory sensitive and like, you know. Do I need it? Oh, wait, no, I still need Explorer just so the Windows version's visible. Okay, and... Right, I wanted to run 7-zip, so... I'm not sure, like, if this runs hotter or not. Okay, it runs way cooler. It's running at like 70 degrees, whereas Y-Cruncher was going over 90. Okay, well, let's see if this is any good as far as 7-zip scores go. Okay, well, considering that all the top scores are over 300,000. Okay, this is looking... Yeah, this is... Yeah, this is terrible. Oh, this is junk. I kind of expected that. Yeah, that's literally... I'm not even going to bother saving it. Okay. Yeah, I'm not saving that. That's garbage. Well, that'll be it for the stream. And yeah, I kind of like, other than the kind of, like, I don't know if that's the motherboard's fault, but other than the, like, I guess, man, here, okay, so here's the issue, right? If I want to test this motherboard with the 265KF, then it's going to delay the 270K plus content again. And it's just like, I don't want to delay it anymore. So that's kind of a problem. So I guess I'm just going to test the 270K plus on this and, you know, at like 8466 because, yeah, I can't get it to go higher currently. Anyway, thank you for watching. Thank you for the 1 super chat. Yeah, I don't know when the 270K plus content is going to be done. Hopefully soonish, because, like, you know, my main interest in it is just having comparison data for other CPUs. And then also being able to test, like, also I want to test other motherboards, which, yeah, I guess I'm going to have to retest the stuff I did with the OC formula. So, I don't know, I'm going to, how am I guess I'm just going to label those columns as OC formula and then, like, shuffle things around to make things work out like that. Anyway, yeah, that's it for the stream. So, thanks for watching. If you'd like to support the channel, there are links in the description you could check out, and that's it. So, goodbye, I guess.